Behind every KFC bucket is a factory operation built for speed and mouthwatering perfection on a massive scale. Every day, thousands of pounds of chicken are seasoned and fried using a tightly controlled process that delivers the iconic taste loved around the world. In this documentary, we go inside the high-powered production lines that keep the buckets full and the flavor consistent. Get ready to uncover how KFC's legendary fried chicken is made. It all begins with the careful sourcing and intake of raw chicken, a process that is both biologically sensitive and highly mechanized to maintain consistent quality and food safety. The chickens destined for KFC facilities are selected from specific poultry farms that follow stringent guidelines set by both KFC's corporate standards and local regulatory bodies. These farms raise broiler chickens, a breed specifically developed for rapid growth and high meat yield, particularly in the breast and thigh areas. To ensure consistency in texture and flavor, the birds are typically grown under controlled feeding regimens with strict monitoring of their diet, environment, and health status from hatchery to harvest. Once the birds reach the appropriate weight and age, usually between 5 to 7 weeks, they are transported live in temperature-regulated, well-ventilated trucks to the processing facility. Upon arrival, the birds are unloaded through an automated conveyor system and transferred to a staging area that uses dim lighting and gentle sound cues to keep the animals calm. This pre-processing environment is crucial for maintaining meat quality, as high stress can cause conditions like pale, soft, and exudative meat, or dark, firm, dry meat, which are both unsuitable for KFC's strict quality requirements. The first critical step in the factory is stunning, which is done using controlled atmosphere stunning, a method that introduces carbon dioxide in gradually increasing concentrations to render the chickens unconscious. This technique is widely considered more humane and helps preserve the quality of the meat. Once the birds are unconscious, they move to the next stage, where an automated system makes a precise incision to the neck, ensuring rapid and thorough bleeding. The bleeding process is closely timed and monitored using sensors and timers to maximize the efficiency of blood removal, which is essential not only for meat appearance and shelf life, but also for meeting food safety regulations. Following exsanguination, the birds proceed through a high-capacity scalding tank filled with water heated to approximately 60 degrees Celsius. This stage loosens the feathers by relaxing the collagen in the feather follicles. The duration and temperature are controlled to a fine margin to ensure that the skin is neither overcooked nor damaged. After scalding, the birds are transferred into rotary feather pluckers, drum-shaped machines lined with soft rubber fingers that rotate at high speeds. These fingers remove feathers through a gentle abrasive action. Any residual feathers, particularly around the wings and tail, are removed by additional targeted plucking devices or hand finishing stations, depending on the processing line speed and factory setup. The next step is evisceration, a highly mechanized process involving robotic arms and vision-guided machinery. The system first makes a precise incision along the abdominal cavity before extracting the internal organs. This includes the heart, liver, gizzard, and intestines, which are separated into byproduct streams for different uses or disposal. Each carcass is inspected by high-speed cameras equipped with AI-powered image recognition software to detect any abnormalities such as bruising, discoloration, or contamination. Chickens that fail this inspection are automatically diverted from the production line for further examination or removal. This real-time quality assurance technology helps maintain a consistent and safe supply of chicken for further processing. Now it's time to move on to the chilling process, which is absolutely vital for halting bacterial growth and ensuring a clean transition from slaughter to further cutting and seasoning. KFC factories typically use an immersion chilling method, where eviscerated chickens are conveyed through long stainless steel tanks filled with chlorinated cold water, maintained at around 0 to 4 degrees Celsius. The flow of water is designed in a countercurrent pattern, meaning the cleanest water contacts the most recently added chickens, ensuring optimal hygiene. This step rapidly reduces the internal temperature of the chicken from roughly 40 degrees Celsius to below 4 degrees within an hour, thereby locking in freshness and significantly extending the shelf life of the meat. After chilling, the carcasses proceed to the cutting and portioning stage. This part of the process is perhaps one of the most intricate in the factory. Specialized rotary cutting machines equipped with lasers and 3D scanners assess the size and density of each chicken in real time. Based on this data, programmable robotic blades segment the carcasses into uniform cuts: legs, thighs, wings, breasts, and keels. Each piece is sized to match strict dimensional and weight criteria, which are crucial for ensuring consistent cooking times and presentation across all KFC restaurants worldwide. The system is calibrated to yield the optimal number of each type of piece from every bird, reducing waste and maximizing efficiency. If a cut doesn't meet the precise size range, it is automatically redirected for use in alternative products like tenders or popcorn chicken. The next phase focuses on marination, a process that introduces moisture, flavor, and functional ingredients into the chicken to enhance both taste and texture. Once portioned, the chicken pieces are loaded into massive stainless steel tumblers, each capable of holding hundreds of kilograms of product. Inside the tumbler, a proprietary liquid marinade blend is introduced. While the exact formulation is a closely guarded secret, the marinade typically includes salt, phosphate-based tenderizers, flavoring agents, and sometimes buttermilk solids to create the tender, juicy interior that KFC is known for. The tumbling action lasts anywhere from 15 to 30 minutes, depending on the batch size and desired intensity. And the drum rotates on multiple axes to ensure that every surface of every piece of chicken is exposed to the marinade. This mechanical agitation also helps the meat fibers absorb the liquid more thoroughly, contributing to the product's juiciness even after high temperature frying. But up next comes the breading stage, which is arguably the most iconic part of KFC's production process. After marination, the chicken is gently drained and transferred to the breading stations, where each piece is coated in the proprietary blend of flour and seasoning known famously as the 11 herbs and spices. To replicate the hand-breaded quality that KFC is known for, even at industrial scale, specialized breading drums are used. These drums simulate the hand-tossing action by gently rolling the chicken pieces in the seasoned flour, while pneumatic paddles and vibration systems ensure that every crevice is fully coated. At this point, moisture content is carefully controlled to ensure adhesion without creating clumps or overly moist surfaces, which would ruin the crispy texture during frying. Once breaded, the chicken moves immediately to the par frying or pre-frying stage. This step is critical for setting the breading so it doesn't fall off during full cooking at the restaurant. The breaded pieces are passed through continuous fryers filled with hot oil maintained at temperatures between 170 to 180 degrees Celsius. In this stage, the chicken is fried for a short duration, usually 90 to 120 seconds, just enough to solidify the coating and begin the Maillard reaction, which is responsible for the development of flavor and the golden color. The oil used in this step is filtered and refreshed continuously using an inline oil management system that maintains optimal frying conditions and ensures that the final product is never tainted by burnt residues or off flavors. The partially cooked chicken is then lifted out of the fryer via a conveyor system and deposited onto a draining belt that uses both gravity and air jets to remove excess oil. Now, it's time to transition to the flash freezing process. This is where partially cooked chicken is rapidly frozen to lock in all the flavors, textures, and moisture absorbed during marination and breading. Each piece is conveyed into a spiral freezer or impingement freezer, both of which use sub-zero air blasts or liquid nitrogen vapor to drop the temperature of the chicken from over 60 degrees Celsius to below minus 18 degrees in under 10 minutes. Rapid freezing is crucial to prevent the formation of large ice crystals, which can damage the cellular structure of the meat and result in dryness or texture loss after final cooking. During this process, each piece is also individually quick frozen, which prevents clumping and allows for precise portioning when packaging. The next step in the factory process is the automated packaging of the individually quick frozen, par-fried chicken pieces, a phase that combines high-speed precision machinery with meticulous control over product integrity. Once the chicken emerges from the spiral or impingement freezer, each piece is conveyed to a sophisticated vision inspection system that performs a final quality assurance check. High-resolution cameras and laser scanners examine each piece for uniform breading coverage, appropriate size, and the absence of any structural defects like broken bones or irregular shapes. Pieces that fail this inspection are removed from the line using targeted air jets and routed for rework or disposal, depending on factory protocol. Once the pieces pass inspection, they are conveyed into a portioning station where intelligent weighing and sorting systems group them into standardized sets that align with KFC's iconic bucket meal configurations. These could be 8-piece, 12-piece, or 16-piece configurations, depending on the regional product lineup. Multi-head weighing machines calculate the total weight and count of each portion, ensuring that every pack not only meets visual and compositional standards, but also falls within a narrowly defined weight range for inventory accuracy and consistent customer experience. These grouping systems operate at incredibly high speeds, hundreds of portions per minute, with tolerances as tight as +1 gram. Each portion of chicken pieces is then dropped into a form-fill seal machine or into pre-formed plastic pouches, depending on the final packaging format. The form-fill seal machines shape a plastic film into a bag, load it with chicken, flush it with a nitrogen-rich gas to minimize oxygen, and heat seal it in a continuous, uninterrupted process. Modified atmosphere packaging is used here to extend shelf life while preventing freezer burn or flavor degradation. The gas blend, often a mix of nitrogen and carbon dioxide, inhibits microbial growth and oxidation without adding any chemicals or preservatives. After sealing, the packages are labeled with all necessary tracking and compliance information. High-speed thermal transfer printers apply labels that contain lot numbers, plant codes, production timestamps, and freeze dates. These labels also include data matrix barcodes or QR codes used for traceability, allowing KFC's central quality control teams to trace every package back to its exact farm, batch, and processing line in the event of a recall or audit. Automated verification systems scan each label for accuracy and readability. Any incorrectly labeled packages are automatically rejected from the line and placed in a designated review bin for manual inspection. Now it's time to move on to case packing, where multiple individually sealed packs of chicken are grouped into corrugated cardboard boxes, each built to withstand long-distance cold chain transportation. Robotic arms equipped with vacuum suction grippers pick and place the sealed bags into the boxes with extreme precision, ensuring that space is maximized while maintaining the integrity of the chicken. Each case typically holds a specific number of meals or bucket configurations and is marked with a unique identifier. Once filled, the boxes are sealed using automated taping machines and pass through weight verification stations to ensure each box matches the expected load. Once packed, these boxes are stacked onto pallets using robotic palletizers. These robots follow pre-programmed stacking patterns that balance weight and maximize vertical space without compromising stability. Slip sheets and corner boards are often inserted between layers to protect the boxes during transit. Each completed pallet is then shrink wrapped using a rotary arm or turntable stretch wrapper, which encases the entire stack in several layers of industrial plastic film to secure the load for transportation. A final barcode label is applied to each pallet, integrating it into the warehouse management system, which tracks every movement of inventory from production to dispatch. Next comes the crucial cold storage phase. The finished pallets are transferred via automated guided vehicles or high-speed conveyor systems into a massive cold storage facility, maintained at a consistent temperature of minus 18 degrees Celsius or lower. These storage facilities are designed with energy efficiency and inventory management in mind, often featuring high bay racking systems and vertical lift modules that allow for dense, organized storage. Temperature and humidity are monitored continuously by sensors linked to a centralized control room where technicians receive alerts if any deviations occur. These warehouses are often equipped with backup generators and emergency protocols to ensure uninterrupted refrigeration in the event of power failures. After sufficient time in cold storage, which may range from a few days to several weeks depending on demand, the frozen chicken pallets are scheduled for distribution. The dispatch process begins with a pick and pack phase, where orders from various KFC regional hubs or franchise warehouses are collated. Advanced logistics software optimizes which pallets to pull based on freshness, production date, and delivery location. Selected pallets are loaded onto refrigerated trailers that maintain a controlled environment throughout the entire journey. These trucks use insulated walls and powerful refrigeration units that can be monitored remotely to ensure temperature compliance from factory to franchise. As these trucks transport the frozen chicken to regional KFC distribution centers or directly to individual restaurants, the cold chain is never broken. The receiving locations are equipped with cold storage facilities of their own, ensuring the chicken remains at safe temperatures until it's needed. At this stage, each restaurant receives a specific allocation based on forecasted customer demand, which is calculated using advanced demand planning software linked to point-of-sale data and regional market trends. The chicken remains sealed until it's ready to be used in the restaurant's kitchen, where the final stages of cooking take place. But now it's time to dive into the heart of the KFC restaurant kitchen, where the transformation from pre-cooked frozen chicken into the hot, crispy, golden brown pieces we all recognize occurs. After thawing in temperature-controlled refrigeration units for a specific number of hours, typically overnight, the chicken is brought to the breading station. Though the chicken was par-fried and breaded at the factory, a second layer of fresh breading is applied in-store to create the distinctive double crunch texture KFC is famous for. This is where the Colonel's proprietary 11 herbs and spices come into play. Each restaurant receives sealed tubs of this secret seasoning blend, pre-measured and tamper-proof. The thawed chicken pieces are first dipped into a cold, seasoned egg wash or a specialized batter mix, depending on the region. Then, they are placed into large breading bins containing the flour and spice mixture. Trained team members follow a specific press and fold technique, which involves pressing the flour onto the surface of the chicken and folding it multiple times to ensure full adhesion and the formation of the characteristic craggy, crispy coating. Each piece is then gently shaken to remove excess breading and laid out on wire racks to rest before frying. This resting period is short but essential. It allows the coating to set and adhere to the surface of the meat, reducing slippage during frying. Next, the chicken is placed into large open fryers filled with high stability frying oil, often a soybean or canola blend, optimized for high temperatures and neutral taste. The fryers are preheated to exact temperatures, typically around 170 to 180 degrees Celsius, and the chicken is cooked under pressure for a controlled duration. KFC's use of pressure fryers is a distinctive element of its cooking process. The pressure cooking not only reduces cooking time, but also seals in moisture, ensuring the chicken remains juicy while achieving a perfectly crispy exterior. Sensors inside the fryer monitor oil temperature, pressure levels, and cooking duration down to the second. Once the timer signals completion, the fryer basket lifts automatically, and the cooked chicken is removed using heat-safe tools to ensure safety and hygiene. After frying, the chicken is transferred to heated holding cabinets that maintain a precise internal temperature, typically around 60 to 65 degrees Celsius, for a limited time, usually no longer than 90 minutes, to ensure optimal freshness and food safety. These cabinets are fitted with internal timers and alert systems to prompt kitchen staff when a batch is nearing the end of its holding time. Any product not sold within this window is discarded according to food safety protocols to maintain KFC standards. Now that the chicken is hot, crisp, and ready, it's portioned into the familiar red and white striped buckets. Each bucket is made from food-grade, grease-resistant cardboard, printed with high-resolution branding that remains vibrant, even under heat and oil exposure. The buckets are assembled on site from flat pack form using pop and lock mechanisms and lined with waxed paper liners. The kitchen crew follows strict guidelines when arranging the pieces inside each bucket, ensuring an appealing visual mix of drums, thighs, wings, and breasts. The buckets are then sealed with fitted plastic or cardboard lids to retain heat and are either handed to walk-in customers or packed into thermal delivery bags for transport. The final stretch of the production process involves a complex web of quality assurance protocols, food safety audits, sustainability initiatives, and continual technological improvements, all of which are critical to ensuring that every KFC fried chicken bucket, whether purchased in Tokyo, New York, or Johannesburg, meets the same high standard of taste, appearance, and food safety. These behind-the-scenes systems may not be visible to the end consumer, but they represent the foundation of KFC's global manufacturing and supply chain model. One of the most rigorous systems in place is the Hazard Analysis and Critical Control Points, or HACCP, framework. This is applied across all phases of the production lifecycle, from live animal handling at the poultry farms to final packaging at the restaurant level. Every critical control point is identified, monitored, and logged digitally. For example, in the chilling process, sensors verify that the internal temperature of chicken pieces drops to below 4 degrees Celsius within a very specific time frame. If any batch fails to meet that requirement, the system will automatically flag the anomaly, prevent further processing, and isolate the affected lot until a manual inspection is completed. These digital controls are complemented by human oversight. Trained quality control technicians regularly inspect samples at random, visually assessing breeding adhesion, meat color, texture, and aroma. At the plant level, sanitation is treated as a mission-critical activity. Every line, blade, and conveyor is cleaned on a strict schedule using a validated multi-step process that includes rinsing, application of food-grade alkaline and acidic detergents, hot water sanitizing, and ATP testing to detect any microbial residues. Cleaning in place systems are used in closed-loop systems like marinade blenders and oil filtration units, ensuring deep sanitation without the need for dismantling complex machinery. Swabs are taken from surfaces and air samples collected to detect airborne pathogens, all analyzed in on-site microbiological labs. If even a trace of Listeria, Salmonella, or E. coli is detected, entire zones of the plant are shut down and sanitized before production can resume. In parallel to these food safety systems, sensory panels and culinary scientists at centralized R&D hubs conduct organoleptic tests to ensure product consistency. These tests assess everything from the crunch of the breading to the juiciness of the meat and the aroma released when the bucket is first opened. Chicken from multiple plants is cooked and compared side by side in blind taste tests to identify deviations in flavor or texture. If a factory's output strays from the baseline profile, its formulations and techniques are reviewed. In some cases, regional adaptations are permitted. For instance, a slightly spicier breading formula in Southeast Asia, or a less salty blend in Scandinavian markets. But these must be approved through corporate sensory panels and extensive pilot runs. Now it's time to take a look at how traceability and supply chain visibility are achieved at scale. Every piece of chicken can be traced through a blockchain-based system that logs data from farm to fryer. RFID tags and barcode labels track each pallet, batch, and case throughout its journey. When a truck departs a cold storage warehouse, its GPS location is monitored in real time, and its refrigeration status is transmitted back to the operations center every 5 minutes. If a delivery truck's temperature rises above the acceptable range for more than 10 minutes, alerts are sent automatically and corrective actions are triggered, either rerouting to a nearby cold facility or discarding the load, depending on the severity of the excursion. Once the product reaches the restaurant, the store-level staff become the final link in the quality chain. Every team member is trained not just in food preparation, but in safe handling and equipment calibration. They measure oil temperatures with infrared thermometers before every cooking cycle, check holding cabinet thermostats each hour, and perform timed inventory rotations to prevent expired stock from being used. Any discrepancies are flagged in a digital checklist that is reviewed daily by shift supervisors and weekly by regional managers. Corporate auditors also perform unannounced inspections using checklists derived from international food safety certifications such as ISO 22000 and BRC Global Standards. But up next is a growing area of emphasis for KFC's manufacturing process, sustainability. As environmental concerns increasingly shape consumer expectations and regulatory policy, KFC and its supply chain partners have invested heavily in reducing their environmental impact without compromising efficiency or food safety. For instance, many factories now operate on hybrid energy models that integrate solar or wind power into the grid supply. Heat exchangers capture and recycle waste heat from fryers and ovens to preheat water for cleaning cycles. Water treatment plants have been installed adjacent to major facilities to purify and reuse water from scalding tanks and chilling baths, thereby reducing freshwater consumption by up to 60%. Waste management is another cornerstone of sustainable operations. Offcuts, bones, and organ meats removed during the evisceration process are rendered into protein meal for use in animal feed or fertilizer. Oil used during the par-frying phase is filtered multiple times and eventually recycled through third-party processes into biodiesel or industrial lubricants. Even the breading flour that falls off during coating is collected, sifted, and reused within the same batch cycle if it remains uncontaminated thanks to high-speed sifters and air classification systems. Packaging materials are continuously redesigned to reduce plastic use, and many regional markets have adopted compostable or recyclable buckets made from sugarcane fiber or recycled cardboard. Now let's touch on automation and the future of food manufacturing. KFC's supply chain continues to push the boundaries of factory automation. Smart robotics now handle everything from chicken loading and cutting to box folding and pallet stacking. Machine learning algorithms analyze yield patterns, worker performance, and maintenance schedules to optimize output while minimizing downtime. Vision systems are paired with artificial intelligence to assess product quality in real time, not just based on weight and shape, but also by identifying anomalies invisible to the human eye, such as microfractures or uneven breading density. One of the most promising developments is the integration of digital twins, virtual replicas of entire production lines that allow engineers to test modifications in real time before applying them in physical factories. If a new breeding formula is under development, it can be modeled digitally to predict how it will behave under tumbling, par-frying, and freezing conditions. These simulations save weeks of trial and error testing and reduce waste. Some facilities even employ predictive maintenance systems powered by sensors embedded in critical equipment. These sensors monitor vibration, temperature, and pressure, allowing for preemptive repairs before machinery fails, ensuring smooth operations and uninterrupted chicken production. KFC has also begun exploring vertical integration of its logistics chain. In some regions, specially designed micro-factories are situated closer to major urban centers, reducing transit time and carbon emissions. These micro-factories handle final stage breading and par-frying, enabling fresher product delivery and enhanced responsiveness to demand fluctuations. Combined with real-time sales analytics from thousands of KFC restaurants, These decentralized production nodes can respond dynamically, ramping up or down based on foot traffic, promotions, or seasonality. Today's journey towards KFC tenders begins in the serene environment of this amazing poultry house, which is located in the United States. Being KFC's biggest supplier, these farms are not just places where chickens are raised. They are carefully designed spaces dedicated to the well-being of the birds. Automatic dispensers play a key role in maintaining the chicken's health. Fresh, clean water is always available thanks to these dispensers. In spacious barns, chickens are given room to roam freely, unlike the cramped conditions found in some other farming setups. This freedom is crucial because a stress-free environment helps the chickens grow healthy and robust. Once the chickens are deemed chicken collection ready, these modern collecting machines arrive at the farms. These machines are somewhat like large vacuum systems, but with a gentle touch. Instead of sucking up the chickens roughly, they handle them with great care. Once the chickens are collected, they are placed into clean, secure crates. These crates are specifically designed to ensure the safety and comfort. This helps reduce stress and keeps them calm throughout the trip. Upon arrival at the processing plant, the chickens are unloaded with the same care and attention they receive throughout their journey. The unloading process is handled by experienced workers who use a bunch of conveyor belts and understand the importance of gentle handling. The focus remains on maintaining their health and safety, which is crucial for producing high-quality products. The processing plant is a marvel of modern technology, designed to handle large volumes of chickens while ensuring efficiency and precision. As the chickens travel along the conveyor belt, they pass through a stunning machine. This machine is designed to render the chickens unconscious in a way that is both quick and painless. One of the most important steps in the processing plant is ensuring the chickens are treated humanely. This commitment to humane treatment reflects the industry's focus on animal welfare. The chickens move to the feather removal stage. This is where a specialized machine removes all the feathers from the chickens. One of the first steps involves separating the chicken feet from the rest of the body. After the feet are removed, the chickens move on to the next stage, where their internal sections are cleaned out. Once the internal cleaning is complete, the chickens are thoroughly washed. The washing process is held in a pool of water that also uses high-pressure water jets to remove any remaining blood or impurities. With the chickens dried, the next stage involves cutting them into various parts, keeping the breast pieces for KFC tenders processing, as they are known for their juicy tenderness. The rest of the chicken will also be cut into pieces and collected for further selling purposes. I almost forgot, but the machines, before making cuts to the breast pieces, use abrasive roller pins to conveniently remove the skin from the breast piece, so you never have to compromise on taste and quality. Specialized machines are used to make precise cuts, separating the breast from the rest of the chicken. These machines are designed to handle the chicken gently while ensuring that each cut is clean and accurate. The breast pieces are cut from the bony parts of the chicken, which are handled separately. Once the chicken breasts are separated from the rest of the chicken, they are carefully collected. Now, the breast pieces are being placed into drum rollers. This part of the process is designed to make the chicken breasts even juicier. The drum rollers gently tumble the chicken pieces, allowing them to lock in moisture and enhance the overall tenderness of the chicken. After the drum rollers, the chicken pieces move to the sorting stage. Here, they are manually placed on running belts, more like sieves. These sieves allow experts to inspect each piece carefully to ensure that the chicken is safe to eat. The pieces are then sprayed with a solution responsible for removing any harmful bacteria from the surface. The spray helps to reduce the risk of contamination and ensures that the chicken is clean and ready. We are really working hard to entertain you guys. If you think we deserve your like, please hit that like button. Once the chicken pieces are thoroughly cleaned, they are coated with flour to create a delicious texture for the chicken and help in forming a crispy coating when fried. Importantly, no artificial ingredients are used in this flour coating. The flour-covered pieces are then transported on shaker or vibrating belts, which ensure that the coating is applied evenly and that the pieces are aligned in a uniform shape. This partial frying locks in the tenderness and juiciness of the chicken while giving it a golden brown color and a crisp texture on the outside. Cheese cubes are a popular snack and ingredient in many dishes, prized for their gooey, melty centers and crispy coatings when fried. The battered cheese cubes are passed through a bed of breadcrumbs in the automatic machine. These machines not only increase efficiency, but also ensure consistency and quality in the final product. By automating the process, manufacturers can produce large quantities of cheese cubes with perfect coatings every time. From mixing ingredients to packaging the final product, every step is designed to create patties that are not only delicious, but also made with remarkable efficiency. Carrying the capacity of 1,500 liters at a time, they can literally cope with the bigger projects, like more than hundreds of thousands of patties every day. Check out that smooth process to package the burger patties to avoid inconvenience. Enjoying that burger crunch or dreaming right now? Anyways, in both cases, you need to complete that fast food party with chicken nuggets. Even if you don't like those crispy and juicy chicken nuggets, you've got to watch this video that may trigger some taste buds in you. For that appealing golden brown appearance, they fry these nuggets for around 70%, so they will be almost ready when you place your order in restaurants. Automation like these becomes even more fascinating when they give a touch of love and care. Here are two sorts of nuggets being made, and if you ask me, both are something delicious enough to die for. I'm kind of a huge foodie. Freshly harvested potatoes arrive at the factory, where the chosen potatoes are gently loaded onto a conveyor belt. This belt carries them smoothly into the heart of the washing area, where a steady stream of water showers over them. This stage is important in maintaining the potatoes' hygiene and ensuring they are free from any contaminants that could compromise their quality. After the initial rinse, the potatoes enter a brushing and scrubbing phase. Here, soft brushes mounted on rotating cylinders gently massage the potato skins. Once thoroughly washed, the clean potatoes proceed to a drying stage. That's a step which is typically 2 in 1, meaning they keep on drying naturally while moving ahead towards further processing, which will be peeling. Obviously, what else could it be? Potatoes enter the automatic peeling station, where abrasive rollers gently remove their skins so they can be moved to these big choppers, which literally cut the potatoes into uniform chunks. This factory is literally multitasking because it doesn't only prepare potatoes for silky smooth mashed potatoes, but also gets the various forms of potatoes ready for dozens of cuisines. For example, here the special cutters have cut the potatoes into wedge shapes, so potato wedges aren't a hassle. While some of the peeled potatoes are sent for further examination, a bunch of experts pass the good quality potatoes to be cut into halves and packed immediately. Yes, because we can't wait more to show you guys the satisfying process of making mashed potatoes in bulk. To prepare the creamiest and most flavorful mashed potatoes, these experts are boiling the potatoes right on the spot. Meanwhile, in many households like mine, where spare time is literally an issue, already boiled potatoes, boiled a day or two before, are used to make mashed potatoes really quick. But these buddies know never to compromise their crowning taste. When the potatoes are perfectly boiled, the unnecessary water is drained, and the steamy hot potatoes get their Disney oil treatment in a smooth blender. As they are the main character, the blender keeps on rotating, while, bit by bit, butter is added into it to give them a thorough and creamy blend. Talk about creamy. In order to make mashed potatoes creamy and dreamy, they'll pour in a specific amount of milk and mix it all over again. This gives the mashed potatoes a smooth texture, and that perfect consistency makes you crave having more. And there you have it. The superheroes have gone through the ultimate transformation, and the best one, ready to be served as a delicious, creamy side dish or main. It totally depends on your taste. Never underestimate any smaller element, even if it's a small gesture or machine like this nozzle, pouring the equal quantity of mashed potatoes in every batch. It was literally a team effort, but we don't end here. There's a lot more craziness to watch, so stick with us. One of the famous international frozen pizza companies is on a mission to create the most delicious pizza ever. So, starting off right with smooth and fluffy dough, which is balled up and spread out neatly in thousands of pizza pans for quick and partial baking. Meanwhile, the pizza sauce is being prepared and neatly spread over the baked dough by some automatic machines, so they do not really need manual help. You know, cheese could go bad, so before it may ruin the entire pizza party, they check it for its top-notch quality beforehand. If it's good enough, the crushers shred the entire cheese blocks and sprinkle them over thousands of pizzas to give these pizzas a perfect texture. Some more cheese slices are neatly added onto them to finish it off. They pour some other sauces and ingredients, so the pizzas are ready to be frozen right away. Finally, the pizzas are covered with a transparent food sheet and packed into boxes to keep them fresh and preserved. These machines won't even demand appreciation, but they do deserve it, right? So hit the like button for the sake of these and many such robotic machines working tirelessly to give you the perfect outcome every time. Just check out how this ordinary-looking dough is going to transform into the perfect buns with a single push of a button. Yes, this entire automation you're watching right now on your screens doesn't involve manual help. Once balled up and rested in their dedicated pans, these fluffy dough balls are kept for a couple of minutes until the dough rises again, and the vacuum can blow off extra crumbs to give it a neat finishing look. However, when the buns are perfectly baked, they are all set to get dressed. Hey, if you like our video, please give it a thumbs up and support us for creating more of such content for you guys. As I always say, you're all we have. Look at those nozzles pouring out the delicious jam on each half to give the best mouth-bursting flavors. Let's indulge in the golden sweetness of honey candies, where each bite is a taste of pure honey. Here, the process begins with the blend of pure honey and other required ingredients, transformed by super smart rollers into a thick, delightful mixture. Rolled out consistently and kneaded thoroughly. Just look at that consistency. It's so rich and smooth. This is so beautiful. How these machines continuously knead the candy material without taking a break to make sure it perfectly fits your standards. Now, that little automated machine makes sure that each candy gets the perfect and desired shape and cut. As the candies move through the production line, quality control sensors monitor each piece. These sensors check for consistency in size, shape, and texture. Once the candies have cooled and set, they are transferred to the wrapping machine. This machine wraps the bunch of candies in protective packaging, keeping them fresh and preventing them from sticking together. Each pack holds around 9 candies, loved worldwide for their pure taste and eye-catching packaging. The candies are then packaged into boxes using huge packaging machinery. This step prepares the candies for distribution and makes them ready for shipping. Stop messing with your sweet tooth nature. Not everything sweet is worth tasting. So grab only your favorite honey-topped biscuits that are rich in taste and super affordable. Do tell me when you find one. Jelly Belly candies are true gummy candies that are crispy from the outside, but a mouthful of liquid flavor bursts into your mouth as soon as you munch them. First, they mix these ingredients together in a big machine until it's just right. Once the mix is ready, the machines pour it into molds to shape the candies. Now it's time for their rest, which is not going to take so long. Once the candies cool down, they're taken out of the molds and spun around in a special machine. This makes sure they're the perfect size, shape, and texture. They make lots of candies this way, so there are tons of flavors to try. With so many different flavors, there's a Jelly Belly for every mood, and you're sure to find one you love. They make sure everyone can enjoy their favorite flavored candy and have a great time eating it. With so many different tastes, from fruity to sweet and everything in between, you'll never get bored. They surely turn snacking into a fun journey where you can discover your new favorite flavor with every bite. When it comes to comparing super smart machines with human hands, robotic machines take the cake. They do everything super fast, perfectly, and with precision. Like right now, these machines are helping to create thousands of baked crusts to be filled with different sweet and savory sauces later by bakeries and restaurants. Loads of fresh meat are brought in and fed into a super fast chopping machine. This machine cuts it all up into equal-sized pieces and packs them neatly into cans. They seal each tin tight with a cover and label using robotic hands in very little time. Creating perfect and smooth dough is a challenging task for human hands. However, for a magical machine, shaping it into equal-sized pieces is no big deal. As soon as the dough is ready and balls are prepared, they undergo a smooth waffle-making machine that rolls them up while baking them in the meantime. This ensures no additional time is wasted, and the result is just hilarious. In today's busy time, sandwiches are considered the perfect meal. Just pair one with a cup of coffee or tea for an easy energy boost. Advanced machinery prepares these sandwiches automatically, taking less time than you can imagine while packing a full energy punch. Different fruit flavors become uniquely delicious when enjoyed in various ways. Transforming the amazing juice and fresh fruit flavors into sweet delights and candies is a breeze for robotic machines. Advanced machinery ensures these flavors are smooth and their textures consistent, making the taste incredibly delicious and enhanced. Robotic machines cut, shape, and create perfectly equal-sized candies in bulk in the blink of an eye. The candies are moved to be wrapped in beautiful, eye-catching wrappers, ready to be enjoyed. Watch this video and you'll see how these machines make the perfect donut-shaped sponge cakes, which later will be topped and dipped into creamy and rich chocolate. Each donut is uniformly crafted and beautifully finished. To enhance the creamy flavor, a drizzle of chocolate syrup is added on top to make every bite a delightful experience. After finishing, they move on to the next process. Here's how sushi goes from a simple idea to the delicious rolls you love. Let's explore the world of sushi, where rice meets seaweed and every roll tells a story. Let's start with the star of the show, rice. First, the workers scoop up high-quality sushi rice and put the stock through sieves to make sure only the best quality grains make it to your plates. Now it's time to get them soaked in water to get the perfectly cooked sushi rice. Here, the rice pots are getting ready, and check out that one-push automation making everything pretty simple. Large machines are going to cook the rice in big batches, so they need to make sure everything gets in place. While the rice is rinsed multiple times until the water runs clear, they add a little bit of vinegar and oil to cook the rice up to the mark. Letting them settle for a moment, the pots are put over the stoves. These machines use precise temperature controls and timings to ensure the rice is cooked perfectly every time. Pretty good if they can check the right moisture and consistency. The rice is steamed and cooked until it's soft and fluffy, just perfect for sushi rolls. Garnishing with a little bit of oil will help to move the rice smoothly. The rice is gently stirred to make sure every grain gets coated with seasoning so that the flavorful rice sticks together just right. The seasoned rice is then cooled to the perfect temperature for rolling. Let's watch the preparation of the rest of the ingredients to make thousands of perfect rolls of sushi. With everything ready, now comes the fun part: assembling the sushi rolls. The machines spread the seasoned rice onto the conveyor belt while the workers place the meats and veggies on top of the rice as it moves on a conveyor belt. From fresh, crisp vegetables to seaweed and other picked ingredients to enhance the flavors. Everything is all lined up for this step. The precise placement of these ingredients is crucial for ensuring that every sushi roll has a balanced flavor and texture. Thanks to the labor that finally made it possible, allow me to show you these beautiful scenes. Finally, the rice and filling are rolled up to make the delicious sushi rolls. This would all be done with the help of these rolling machines, which will perfectly roll out the assembled sushi sheets. Just look at those enormous sushi rolls. Aren't they mouth-watering? This one was a billion times satisfactory adventure that I'm never going to forget. The workers now cover the sushi rolls with seaweed sheets and feed the sushi rolls into the machine that slices the big rolls into bite-sized pieces. The ready-to-eat rolls are now all set to get covered inside the special packaging, which seals them to keep them fresh. Now let's set off on a tasty journey of the production of your favorite snack, kimbap. Workers carefully add a mix of spicy sauces to the freshly cooked rice. This blend of flavors gives the kimbap its unique kick. The rice is stirred with precision to make sure every grain is coated with that zesty, spicy goodness. After the rice gets its spicy makeover, the machines spread it evenly, and it is then topped with meat or other preferences and sauces to add crunch and color to each kimbap pack. This is exactly how kimbap gets its crowning triangular shape. This shape makes them easy to grab and even easier to enjoy. Each piece is carefully cut to make sure it's just the right size for a perfect bite. The neatly cut kimbap pieces are placed into individual packs. Each pack is sealed tightly to keep the kimbap fresh and flavorful. And that's how your favorite kimbap packs come to your plates. Let's now move on to another beloved snack, crispy fried chicken nuggets. These nuggets are a favorite among people of all ages, and their production process is as fascinating as their taste. First, large quantities of fresh chicken meat are brought into the factory and prepared for processing. The chicken pieces are carefully cut into uniform shapes and sizes by high-speed chopping machines, ensuring each nugget is consistent. Once cut, the chicken pieces are passed through a marination station where they are coated in a blend of herbs, spices, and seasoning. The marination process ensures that every bite is packed with flavor. After marination, the nuggets are passed through a battering station where they are evenly coated in a smooth, flavorful batter. Following this, the nuggets move to the breadcrumb coating stage. This step ensures the nuggets get their signature crispy texture after frying. The coated nuggets are then partially fried. This partial frying process locks in the juiciness of the meat while giving the nuggets a golden brown color and a crispy outer layer. After partial frying, the nuggets are rapidly frozen to preserve their freshness and flavor. They are then packed into airtight bags and prepared for shipping to various restaurants and retail outlets worldwide. Next, let's talk about potatoes. Potatoes are one of the most versatile foods, and their journey from the farm to your plate is nothing short of extraordinary. After being washed, scrubbed, and peeled, The potatoes are sent through slicing machines that cut them into various shapes. Some are turned into classic fries, others into wedges, and some into thin slices for chips. These potato cuts are then rinsed again to remove any excess starch. They are then partially fried in large industrial fryers. This step ensures that when you cook them at home or they are fried at a restaurant, they will achieve that perfect, crispy texture. After frying, the potato pieces are rapidly frozen and packed into bags, ready to be delivered to your favorite fast food outlets or grocery stores. Now, let's dive into the world of frozen burger patties. Large cuts of fresh beef or chicken are brought into the processing plant, where they are ground into a fine texture. Seasoning is added, and the mixture is carefully blended to ensure even distribution of flavors. The mixture is then fed into patty-forming machines that shape the ground meat into perfectly round patties. These patties are then passed through a cooking tunnel, where they are partially cooked to lock in moisture and flavor. After cooking, the patties are rapidly frozen and packed into individual portions. This ensures they remain fresh and ready for cooking whenever you crave a burger. Next, let's explore the production of creamy mashed potatoes. Once the potatoes are washed, peeled, and boiled, they are transferred to large industrial blenders. Bit by bit, butter and milk are added while the blenders mix the potatoes into a creamy, smooth texture. The mixture is carefully monitored to ensure it reaches the perfect consistency. After blending, the mashed potatoes are portioned into containers using precision nozzles. Each batch is sealed to maintain freshness and is then prepared for distribution. These ready-to-eat mashed potatoes can be found in grocery stores or served at your favorite restaurants. Now let's move on to one of the most beloved treats, honey candies. The process begins with blending pure honey with other ingredients, such as sugar and natural flavorings. This mixture is heated until it reaches the perfect consistency. Once the candy mixture is ready, it is poured into molds to give it the desired shape. After cooling, the candies are removed from the molds and passed through quality control sensors. These sensors ensure that each candy meets the required standards in terms of size, shape, and texture. Once approved, the candies are wrapped in protective packaging to maintain their freshness and prevent them from sticking together. They are then packed into boxes and prepared for shipping. Let's not forget about donuts, a treat that brings joy to people worldwide. The donut production process begins with preparing soft, fluffy dough. The dough is mixed, kneaded, and portioned into uniform shapes using specialized machines. These dough pieces are then transferred to donut fryers, where they are fried until they achieve a golden brown color. After frying, the donuts are cooled and passed through a glazing station, where they are coated with a layer of sweet icing or syrup. Some donuts are also filled with cream, jelly, or chocolate using precision nozzles. Finally, they are packed into boxes, ready to be delivered to bakeries, cafes, or grocery stores. Now let's talk about sushi, an art form as much as it is a meal. The process begins with cooking high-quality sushi rice, which is seasoned with vinegar and sugar. The rice is cooled and then spread evenly on sheets of seaweed by automated machines. Fresh ingredients like fish, vegetables, and sauces are carefully placed on the rice. The sheets are rolled into cylindrical shapes using specialized rolling machines. These rolls are then cut into bite-sized pieces using sharp, automated knives. Each sushi roll is inspected for quality and consistency before being packed into airtight containers. This ensures the sushi remains fresh and flavorful when it reaches your plate. Kimbap, a popular Korean dish, follows a similar process. Freshly cooked rice is seasoned with a mix of sauces and spices. The seasoned rice is spread onto sheets of seaweed and topped with a variety of ingredients, including vegetables, meat, and sauces. The sheets are then rolled and cut into triangular shapes, making them easy to eat. is carefully wrapped in protective packaging and sealed to maintain its freshness. These neatly packed kimbap rolls are then shipped to grocery stores, convenience stores, and restaurants worldwide. In conclusion, whether it's fried chicken, cheese cubes, nuggets, potatoes, mashed potatoes, burgers, donuts, sushi, or kimbap, every product goes through a series of meticulously automated processes. Each step is carefully monitored and executed with precision to ensure quality, consistency, and safety. These automated machines and advanced technologies play a crucial role in delivering your favorite snacks and meals to your plate. From the farm to the factory, and finally to your dining table, every step is a testament to human innovation and the tireless efficiency of modern machinery. The journey of McDonald's French fries begins long before they reach the restaurant kitchens. It all starts with the careful selection and cultivation of the perfect potatoes. Every fry that ends up in a McDonald's restaurant has been through a rigorous process, ensuring consistency in taste, texture, and appearance. The company relies on specific varieties of potatoes, primarily the Russet Burbank, Russet Ranger, Umatilla Russet, and Shepherdie. These potatoes are chosen for their high starch content, which helps create that signature crispy exterior and fluffy interior when fried. They are also selected for their long, uniform shape, which allows McDonald's fries to be consistently straight and evenly sized. Farmers who grow potatoes for McDonald's work under strict guidelines to meet the company's high standards. The soil must be rich in nutrients, well drained, and have the right pH levels to support optimal potato growth. Before planting even begins, farmers carefully prepare the land. The soil is tilled and aerated to improve its structure, allowing the roots of the potatoes to spread evenly. Proper soil preparation ensures that the potatoes will grow uniformly in size and shape, which is crucial for creating the perfect fries. Once the soil is ready, seed potatoes are selected. These are not actual seeds, but small, specially chosen potato tubers that will sprout and grow into full-sized potato plants. Farmers cut these seed potatoes into pieces, making sure each piece contains at least 1 or 2 eyes, the spots where new growth will emerge. These seed pieces are then treated with an antimicrobial solution to prevent disease and are left to cure for a short period before being planted. When the conditions are right, typically in early spring, the seed potatoes are planted in long, evenly spaced rows using precision planting machines. These machines ensure that each seed piece is placed at a consistent depth and distance from the others. Consistent spacing allows the plants to develop evenly, preventing competition for nutrients and ensuring that each potato grows to an optimal size. As the potato plants grow, they require constant monitoring and care. Farmers use irrigation systems to provide a controlled amount of water, ensuring that the plants receive enough moisture without becoming waterlogged. Too much water can lead to rot, while too little can cause the potatoes to develop poorly. Advanced irrigation systems, including center pivot sprinklers and drip irrigation, help maintain the perfect balance. Pest control is another crucial factor. Farmers use integrated pest management techniques, which combine natural predators, crop rotation, and selective pesticide application to keep harmful insects at bay. Keeping pests under control prevents damage to the potatoes and reduces the need for excessive chemical treatments. Throughout the growing season, McDonald's suppliers test the potatoes for starch content, sugar levels, and overall quality. These tests help ensure that the potatoes are developing the ideal characteristics for frying. Potatoes with too much sugar will turn dark when fried, while those with too little starch won't develop the crispy texture that McDonald's fries are known for. When the potatoes reach maturity, typically after 90 to 120 days, the leaves and stems of the plants begin to wither and die. This signals that the potatoes underground are ready for harvest. However, before harvesting begins, farmers often use a technique called vine desiccation. This involves cutting or chemically drying the potato vines to toughen the skins of the potatoes and make them more resistant to damage during harvesting. Harvesting is done using specialized potato harvesters. These machines carefully dig into the soil, lifting the potatoes while shaking off excess dirt. The potatoes are then conveyed into large storage bins or directly into trucks for transport. To minimize bruising and damage, the harvesters are designed to handle the potatoes gently, using soft conveyor belts and cushioned drops. Once harvested, the potatoes undergo a crucial curing process. This involves storing them in temperature and humidity-controlled environments for several weeks. The curing process allows minor cuts and bruises to heal and strengthens the skins, improving their storage life. During this time, the potatoes are kept at a carefully maintained temperature, typically between 45 degrees Fahrenheit and 50 degrees Fahrenheit, to prevent sprouting and spoilage. After curing, the potatoes are stored in massive, climate-controlled storage facilities. These storage units can hold millions of pounds of potatoes and are designed to keep them in optimal condition for months. Proper ventilation is key, as too much humidity can cause mold and rot, while overly dry conditions can cause the potatoes to shrivel. Before the potatoes are transported to processing facilities, they undergo another round of quality control. Samples are taken and tested for defects, size consistency, starch content, and sugar levels. Any potatoes that don't meet McDonald's strict standards are either sent for use in other food products or discarded. Only the best potatoes make it through to the next stage of the process. Now that the potatoes have been grown, harvested, cured, and stored, they are ready for transport to the processing facilities, where they will be transformed into the famous McDonald's fries. Specialized trucks equipped with temperature control systems transport the potatoes to ensure that they remain in perfect condition during transit. The logistics of transporting millions of pounds of potatoes require precise planning to ensure a steady supply of raw materials to processing plants. Upon arrival at the processing facility, the potatoes are unloaded and undergo an extensive inspection process. Workers and automated scanning systems check for any potatoes that might have developed defects during storage or transport. Any potatoes that fail the inspection are removed from the production line. The selected potatoes are then sent into the processing area, where the transformation into fries begins. The next step in the process is cleaning. The potatoes are loaded onto conveyor belts and passed through a series of high-pressure washers and rotating scrubbers. These machines use powerful jets of water and mechanical brushes to remove any remaining dirt, debris, and residual pesticides. The goal is to ensure that the potatoes are completely clean before they are peeled and cut. Once cleaned, the potatoes are sent to industrial steam peelers. These machines use high-pressure steam to loosen the potato skins, making them easy to remove. The potatoes are then tumbled in rotating drums, where the loosened skins are gently rubbed away. This method of peeling is highly efficient and helps preserve as much of the potato as possible, minimizing waste. After peeling, the potatoes pass through another round of inspection. Advanced optical sorting machines use cameras and sensors to detect any remaining imperfections. If a potato has a blemish or an area of discoloration, the machine automatically removes it from the production line. This ensures that only high-quality potatoes continue to the next stage. Now that the potatoes are cleaned, peeled, and inspected, they are ready to be cut into the familiar fry shape. Industrial cutting machines use high-speed water knives to slice the potatoes with incredible precision. These machines use pressurized water jets to push the potatoes through razor-sharp blades at speeds of up to 117 miles per hour. The result is perfectly uniform fries, ensuring consistency in size and shape across every McDonald's location. After being cut, the fries are rinsed in cold water to remove excess surface starch. This step is essential because too much starch can cause the fries to clump together and fry unevenly. By rinsing away the surface starch, the fries maintain their individual shape and crispiness after cooking. Once rinsed, the fries move on to the next critical step in the process: blanching. Blanching is a partially cooking method that helps preserve the fries' texture, color, and flavor. The fries are briefly submerged in hot water at a precisely controlled temperature, which removes additional sugars and further improves the final texture. This step also ensures that the fries achieve their signature golden color when cooked. Now that the potatoes have been washed, peeled, cut, and blanched, the next critical step in their transformation into McDonald's French fries is the drying process. This stage is essential because excess moisture can interfere with the frying process, preventing the fries from achieving the crispy texture that customers expect. After blanching, the fries emerge wet with a thin layer of surface moisture. If this moisture isn't removed, it will cause the fries to absorb too much oil during frying, resulting in a greasy, soggy texture instead of the signature crispiness. To prevent this, the fries are conveyed into an industrial drying system. These drying machines use high-powered air blowers to remove excess water from the surface of the fries. As the fries move along a conveyor belt, large fans blow heated air over them, gradually evaporating the remaining moisture. The temperature and speed of the drying process are carefully controlled, as drying too quickly can cause the fries to develop an uneven texture, while drying too slowly can lead to unwanted starch gelatinization. To ensure consistency, infrared sensors monitor the moisture content of the fries in real time. If any fries still contain too much moisture after passing through the first drying phase, they may be sent through an additional round of drying before moving forward. This step ensures that every fry is prepared correctly before it reaches the frying stage. Once the fries have been properly dried, they are ready for the first round of frying, known as par frying. This is a crucial step in the McDonald's fry making process, as it sets up the fries for their final cooking once they reach restaurant kitchens. During par frying, the fries are submerged in a carefully maintained blend of oils, which typically includes a mix of canola, soybean, and hydrogenated soybean oils. The oil blend is formulated to provide the ideal balance of flavor, crispiness, and shelf stability. Maintaining the right frying temperature is critical. The oil is heated to approximately 335 degrees Fahrenheit, ensuring that the exterior of the fry sets properly without overcooking the interior. The fries are only in the oil for about 45 to 60 seconds, just long enough for their exterior to begin forming a crisp, golden shell. At this stage, the inside of the fry remains mostly uncooked. The goal of par frying is not to fully cook the fries, but rather to create a stable, structured outer layer that will crisp up perfectly when they are fried a second time in McDonald's kitchens. As the fries move through the fryer, automated stirring mechanisms ensure that they cook evenly. The machines continuously adjust frying times and temperatures based on real-time data collected by sensors in the oil. These sensors monitor changes in oil quality, ensuring that the fries cook consistently and that the oil remains fresh throughout the production process. To maintain oil quality, the frying system is equipped with an automatic filtration system that continuously removes food particles and debris. This prevents burn particles from affecting the taste and color of the fries, ensuring that each batch is cooked under optimal conditions. Additionally, the used oil is periodically replaced to maintain consistency and prevent the fries from absorbing any off flavors. Once the fries have been par fried, they must be cooled quickly to prepare them for freezing. The rapid cooling process prevents overcooking and locks in their texture and flavor. As they exit the fryer, the fries are conveyed through a cooling tunnel where cold air is blasted onto them. This brings their temperature down rapidly, stopping the cooking process before they move on to the freezing stage. Now the fries are ready for individual quick freezing, a process that ensures they remain fresh and retain their texture during transportation and storage. Unlike traditional freezing methods, which can cause ice crystals to form and damage the structure of the fries, IQF rapidly freezes each fry in just seconds, preventing clumping and preserving the ideal texture. As the fries move through the freezing tunnel, they are kept in constant motion to prevent them from sticking together. This ensures that when they are later packaged, they remain separate and can be easily portioned at McDonald's restaurants. The IQF process is one of the most important steps in the production of McDonald's fries, as it allows the fries to maintain their signature quality even after being stored and transported over long distances. Without this rapid freezing process, the texture and flavor of the fries would degrade before they ever reach the restaurants. Now that the fries are frozen, they are ready for packaging. The frozen fries are conveyed to the packaging area, where they are portioned into pre-measured bags. The packaging process is highly automated, ensuring precision and consistency. As the fries enter the packaging machines, they pass through electronic weighing systems that measure out the correct amount for each bag. The machines are programmed to fill bags of different sizes, depending on whether they are destined for restaurants or retail sales. Once the correct amount of fries has been portioned, the packaging machine seals the bags using airtight, food-safe plastic. The sealing process is crucial as it prevents moisture and air from reaching the fries, which could cause freezer burn or spoilage. Each bag is then labeled with information such as batch numbers, expiration dates, and storage instructions. These labels ensure that the fries can be tracked throughout the supply chain and that restaurant staff know how to handle them properly. With the fries now packaged, they are moved to storage freezers, where they remain at sub-zero temperatures until they are ready to be shipped to McDonald's locations worldwide. These massive freezers are designed to keep the fries at a stable temperature, preventing fluctuations that could affect their quality. To maintain efficiency, McDonald's employs a sophisticated inventory management system that tracks the movement of frozen fries from production facilities to distribution centers and, ultimately, to individual restaurants. This system ensures that restaurants always receive fresh shipments and that the fries are used in a first-in, first-out manner to prevent older stock from lingering in storage. Now that the McDonald's fries have been frozen and packaged, the next critical step is their transportation and storage. Ensuring that the fries maintain their quality from the factory to McDonald's restaurants worldwide requires a highly coordinated logistics system. Every detail, from temperature control to packaging integrity, must be carefully managed to prevent any compromise in taste, texture, or safety. Once the fries are sealed in airtight bags and labeled, they are transferred into large freezer storage facilities within the processing plant. These storage freezers maintain a consistent temperature of around -18 degrees Celsius or lower, preventing ice crystal formation, which can degrade the fries' texture. The storage rooms are equipped with high-efficiency cooling systems that circulate air evenly, ensuring that no section of the storage area fluctuates in temperature. Inside these freezers, the fries are stacked onto pallets, which hold multiple cases of packaged fries. Each pallet is organized based on batch numbers and production dates, ensuring that inventory follows a first-in, first-out rotation. This method ensures that the oldest batches are always shipped out first, preventing any fries from sitting in storage for too long. Once ready for distribution, the pallets of frozen fries are loaded onto refrigerated trucks. These trucks, known as reefers, are specially designed to transport perishable goods over long distances without breaking the cold chain. Before loading, drivers and logistics personnel conduct a thorough inspection of the truck's refrigeration system to ensure that it maintains the required sub-zero temperatures throughout the journey. As the fries are transferred from the freezer storage to the trucks, time is of the essence. The fries must remain frozen at all times, so the loading process is highly efficient. Warehouse workers use forklifts to move entire pallets of fries onto the trucks in a carefully coordinated sequence. The doors of the truck are kept closed for as long as possible to prevent warm air from entering. And once loading is complete, the truck's refrigeration system is double-checked before departure. Throughout the transportation process, temperature sensors continuously monitor conditions inside the truck. These sensors send real-time data to logistics teams, who can track the temperature remotely and intervene if any issues arise. If the temperature rises even slightly above the acceptable range, alarms notify the driver and logistics managers so that corrective actions can be taken immediately. McDonald's fries travel through an intricate global supply chain, often covering thousands of miles before reaching their final destination. Some shipments are sent directly to regional distribution centers, while others may be shipped overseas using refrigerated cargo containers. In the case of international shipments, frozen fries are loaded into specialized shipping containers equipped with advanced cooling units. These containers ensure that the fries remain at the proper temperature, even during extended voyages across oceans. Once the fries arrive at a McDonald's distribution center, they are unloaded and immediately placed into cold storage warehouses. These facilities operate similarly to the freezer storage in processing plants, maintaining sub-zero temperatures and using the FIFO inventory system. The fries remain in these distribution centers until they are scheduled for delivery to specific McDonald's restaurants. At this stage, delivery trucks equipped with refrigeration units transport the fries from the distribution centers to individual McDonald's locations. These trucks are designed for short-haul deliveries, ensuring that the fries remain frozen while en route to the restaurants. The loading and unloading process is again handled with precision, minimizing exposure to warm air to maintain the fries' frozen state. When the fries arrive at a McDonald's restaurant, they are immediately placed into a walk-in freezer. These freezers, located in the back of the kitchen, are maintained at a constant temperature of -18 degrees Celsius or lower. McDonald's staff follow strict protocols when handling frozen fries, ensuring that the cold chain remains intact. To manage inventory efficiently, McDonald's employees use a stock rotation system that ensures older batches are used first. Staff are trained to check expiration dates and packaging integrity before moving fries from the freezer to the cooking area. If any package shows signs of damage or thawing, it is discarded to maintain quality and safety standards. With the fries safely stored in McDonald's freezers, the next stage of the process begins: preparation and cooking. When an order for fries is placed, restaurant staff retrieve a bag of frozen fries from the freezer and transfer it to the fry station. The fry station is equipped with multiple deep fryers, each filled with a specially formulated blend of oils that have been carefully designed to give McDonald's fries their signature taste and texture. Before frying, the fries are measured out using a portioning system that ensures consistency across all orders. This portioning system dispenses the correct amount of fries into a stainless steel fry basket, preventing over or under portioning. Consistency is a crucial factor in McDonald's operations, ensuring that every customer receives the same high-quality product, whether they are ordering fries in New York, Tokyo, or London. Once portioned, the fries are submerged into the hot oil, which is maintained at a precise temperature of around 345 degrees Fahrenheit. The restaurant fryers are equipped with built-in temperature sensors that continuously monitor the oil and make automatic adjustments to keep it at the optimal frying temperature. If the oil becomes too hot, the fries can burn and develop an unpleasant taste. If the oil is too cool, the fries will absorb too much oil, becoming greasy and soggy. The frying process typically lasts for approximately 3 minutes, during which time the fries undergo a dramatic transformation. The high temperature causes the moisture inside the fries to rapidly turn into steam, creating the crispy outer layer that defines McDonald's fries. Meanwhile, the starches inside the fry undergo gelatinization, giving the interior its signature fluffy texture. To ensure even frying, McDonald's fryers use automated timers and shaking mechanisms that periodically agitate the fry baskets. This prevents the fries from clumping together and ensures that every fry is cooked to perfection. Once the fries have finished frying, the baskets automatically rise out of the oil, allowing excess oil to drain. At this point, the fries are still extremely hot and must be handled with care. They are immediately transferred to a stainless steel holding tray, where they are given their final touch, seasoning. McDonald's fries are seasoned with a precise amount of salt, which is evenly distributed using a specialized shaker. The amount of salt added is carefully calibrated to ensure that every fry has the same level of seasoning. Too much salt can overwhelm the delicate flavor, while too little can leave the fries tasting bland. The fries are then transferred to their final serving containers, whether that be a small, medium, or large fry box. McDonald's packaging is designed to retain heat while allowing some airflow to prevent the fries from becoming soggy. The packaging process is also highly standardized, ensuring that every order looks and feels the same. Ensuring that every McDonald's fry meets the company's exacting standards requires an extensive quality control process at every stage of production. From farm to fryer, each step is carefully monitored and tested to maintain consistency in taste, texture, and appearance. These rigorous quality control measures are essential in producing fries that are identical in every McDonald's restaurant worldwide. It all begins at the potato farms, where McDonald's agronomists work closely with farmers to oversee crop development. Soil conditions, irrigation levels, and growing techniques are constantly evaluated to ensure that the potatoes develop the right starch content and texture for frying. Once harvested, samples from each batch are tested for size, shape, sugar content, and moisture levels. Only potatoes that meet McDonald's specifications are approved for processing. At the processing facility, automated optical sorters inspect the potatoes before they enter production. These machines use advanced imaging technology to detect any imperfections such as bruising, rot, or irregular shapes. Any potato that does not meet quality standards is removed from the line. As the potatoes move through peeling, cutting, blanching, and drying, additional checks ensure that each fry maintains the correct dimensions, moisture balance, and uniformity. One of the most critical quality control steps occurs during par frying. Sensors in the fryers constantly measure oil temperature and frying time to ensure that the fries develop the correct texture and color. Samples from each batch are taken and tested for oil absorption, crispness, and interior fluffiness. If any deviations are detected, adjustments are made to the frying parameters to maintain consistency. Once the fries are frozen, further inspections take place. Random samples are pulled from production batches and tested in lab conditions to ensure that freezing has not affected their texture or flavor. Fries are fried, tasted, and measured for crispiness, color, and moisture retention. Any irregularities result in adjustments to processing equipment or procedures. During transportation, strict temperature monitoring ensures that the fries remain frozen at all times. Sensors in refrigerated trucks and shipping containers provide real-time temperature data, ensuring that any fluctuations are immediately addressed. If a shipment experiences even minor temperature inconsistencies, it may be rejected to prevent compromised product quality. Upon arrival at McDonald's restaurants, employees perform additional checks before storing the fries in freezers. Staff are trained to inspect packaging for any signs of damage or thawing. When preparing fries for customers, they follow precise cooking procedures, including setting timers, checking oil temperatures, and following strict portioning and seasoning guidelines. To further ensure quality, McDonald's conducts random in-store testing. Quality control specialists visit restaurants to sample fries and evaluate their texture, taste, and temperature. These evaluations help identify any potential issues in the cooking process, ensuring that customers receive the perfect fries every time. The manufacturing of Pringles is an intricate process that combines food science, precise engineering, and large-scale automation to produce the uniform, crisp, and stackable potato chips recognized worldwide. Unlike traditional potato chips, which are sliced from whole potatoes and fried, Pringles are created from a specially formulated dough made primarily of dehydrated potato flakes, starches, and seasonings. The process of making Pringles in a factory involves several key stages, each meticulously designed to ensure the final product meets strict quality standards. It all begins with selecting the right raw ingredients, primarily potatoes, which serve as the foundation of the chips. However, not just any potatoes will do. Pringles require specific varieties with the right starch content to achieve the desired texture. High starch potatoes are preferred because they contribute to the crispness of the final chip and help bind the dough together during production. Once the right potatoes are sourced, they are transported in bulk to the factory, where they undergo an initial round of inspection. Before entering the processing phase, the potatoes are stored in climate-controlled environments to maintain their quality. Even small variations in temperature and humidity can affect their starch content, which in turn impacts the final texture of the chip. Workers constantly monitor these storage conditions to ensure that the potatoes remain in an optimal state before processing. When ready for use, the potatoes are moved to the preparation area, where they go through a rigorous washing process. Large industrial washers, equipped with rotating brushes and high-pressure water jets, remove dirt, debris, and any residual pesticides from the potato skins. This step is crucial, as any impurities at this stage could compromise the quality of the final product. The washing process is thorough, ensuring that only the cleanest potatoes make it to the next stage. Once cleaned, the potatoes are sent through a peeling machine, which uses either steam or mechanical abrasion to remove the skins efficiently. Steam peeling is a common method in large-scale food production, as it allows for quick and uniform removal of the skin with minimal waste. The peeled potatoes are then conveyed to slicing machines, but unlike conventional potato chips, where these slices would be fried, the goal here is to break them down into a form that can be processed into a dough. To achieve this, the sliced potatoes are sent through a pre-cooking stage, where they are partially heated to help break down their cellular structure. This step makes it easier to remove moisture later in the process. The pre-cooked potato slices are then transferred to large industrial dryers, where hot air circulates around them, slowly extracting moisture until they are fully dehydrated. What remains after this process is not whole potato slices, but thin, brittle flakes of potato. These dehydrated potato flakes serve as the primary base for Pringles and are stored in large silos within the factory. However, potato flakes alone are not enough to form the distinctive shape and texture of Pringles. Additional ingredients must be added to create the dough that will eventually be shaped into chips. When it is time to begin the production of a batch, the potato flakes are carefully measured and transferred to industrial mixing machines. Inside these massive mixers, the flakes are combined with other ingredients such as cornstarch, wheat starch, emulsifiers, and small amounts of salt and sugar. These additional ingredients help give Pringles their characteristic crunch and structure, while also ensuring that the dough is flexible enough to be shaped without crumbling. Water is then gradually added to the dry mixture, and the entire batch is kneaded until it forms a smooth, pliable dough. This step is one of the most crucial in the entire process, as the consistency of the dough determines how well the chips will hold their shape and how they will fry later in the process. Too much water and the dough will be too soft, making it difficult to handle. Too little and it will become too dry, leading to chips that may crack or break during production. The mixing process is highly automated, with computer-controlled machines ensuring that every batch has the same precise ratio of ingredients. Factories use real-time monitoring systems to adjust the moisture content and consistency of the dough as needed, ensuring uniformity across millions of chips. Any slight variation in dough quality could lead to a final product that does not meet the brand's strict standards, so maintaining precise control over this step is critical. Once the dough reaches the perfect consistency, it is ready to be shaped. However, before this can happen, the dough must be processed into thin sheets. This is accomplished using large industrial rollers, which gradually flatten the dough to an exact thickness. The thickness of the dough sheet is critical as it determines the final texture and crunch of the Pringles. If the dough is too thick, the chips will be too hard. If it is too thin, they may become fragile and brittle. The flattened dough sheet is then conveyed to a cutting station, where specially designed rotary cutters stamp out individual chip shapes. Unlike traditional potato chips, which take on random forms based on how they are sliced, Pringles are designed to be identical in size and shape. Each cutter is engineered to create the precise oval form that allows the chips to stack perfectly inside their cans. During this process, any excess dough that remains after the chips are stamped out is collected and fed back into the mixing stage. This recycling process minimizes waste and ensures that as much of the raw material as possible is used efficiently. The ability to reuse excess dough is one of the advantages of making Pringles from a formulated dough rather than whole potato slices. At this point, the chips are still in their raw, unbaked form. They have been cut into shape, but they are not yet crispy. To achieve their signature texture, they must go through the next phase of the manufacturing process, where they will be carefully molded and cooked. This is where Pringles truly begin to take on their distinctive identity. Before they can be cooked, the raw chips must be shaped into their famous curved form. This is done using a specialized conveyor system that gently places each chip into a custom mold. These molds are designed to hold the chips in a precise curve, known as a hyperbolic paraboloid, which is what gives Pringles their unique stacking ability. The shape is not just for aesthetics. It also helps distribute weight evenly when the chips are stacked in their can, preventing them from breaking easily. Once placed in the molds, the chips are conveyed toward the cooking stage, where they will be exposed to controlled heat and oil. This step is critical in achieving the crispy, golden brown texture that Pringles are known for. However, unlike traditional potato chips, which are deep fried in vats of hot oil, Pringles are cooked in a specialized method that ensures even frying while maintaining their precise shape. At this point, the chips are not yet fully cooked, nor have they been seasoned. The next phase will involve exposing them to heat and oil, followed by a careful seasoning process that gives each chip its final flavor. But before that happens, factory workers and automated quality control systems continuously monitor the process to ensure that each chip is perfectly shaped and free of defects. With the raw dough pieces now cut into their precise, uniform shapes and carefully placed into their curved molds, they are ready to undergo the critical cooking process. This step is what transforms the soft, pliable dough into the crisp, golden brown chips that Pringles are known for. Unlike traditional potato chips that are submerged in deep vats of hot oil and fried freely, Pringles undergo a much more controlled cooking method to maintain their exact shape and texture. The chips, still nestled in their curved molds, travel along a continuous conveyor belt into an industrial fryer. This fryer is designed to ensure that each chip is cooked at an exact temperature for a precise amount of time. The temperature inside the fryer is meticulously controlled, typically ranging between 300 degrees Fahrenheit and 375 degrees Fahrenheit, depending on the specific requirements of the batch being produced. The goal is to remove moisture from the chips without overcooking them, achieving the perfect crunch while preserving the uniform shape. The frying process takes only a matter of seconds, but within that short time, several crucial chemical reactions occur. The high heat causes the remaining water content inside the dough to rapidly evaporate, creating tiny air pockets that give Pringles their distinctive lightness. At the same time, the starches and sugars in the dough undergo the Maillard reaction, a chemical process that causes browning and enhances the chip's flavor by developing rich, slightly nutty, and toasted notes. Because the chips are fried in a controlled environment while sitting inside their molds, they do not curl or warp the way traditional potato chips do. Instead, they maintain their signature hyperbolic paraboloid shape, which is key to their ability to be stacked efficiently without breaking. To ensure even cooking, the oil circulates through the fryer using a sophisticated system that maintains uniform heat distribution, preventing any chip from becoming overcooked or undercooked. Once the chips have been fried to perfection, they must be quickly removed from the hot oil to prevent excessive absorption of fat, which could compromise their texture and make them overly greasy. The chips exit the fryer onto a draining conveyor, where excess oil is gently shaken off. A series of air jets then blow away any remaining oil droplets, ensuring that each chip has the right balance of crispness without being overly oily. The amount of oil that remains in the final product is carefully monitored, as even a small deviation in fat content could alter the texture and mouthfeel of the chips. After the excess oil is removed, the chips continue along the conveyor system into a specialized drying chamber. This drying stage serves a dual purpose. It helps eliminate any remaining moisture to extend the shelf life of the chips and ensures that they retain their crisp texture. If any residual moisture remains, it could lead to sogginess or even microbial growth, which would compromise the quality of the product. The drying chamber operates using a controlled flow of warm air, which gently removes any lingering humidity without exposing the chips to excessive heat. This is a crucial step because over-drying could make the chips too brittle, leading to breakage before they even reach the packaging stage. The process must strike a balance between removing moisture while preserving the ideal crunch. Now that the chips have been properly fried and dried, they still lack one essential component: flavor. While the dough contains some base seasonings, such as salt, the majority of Pringles' signature flavors are added after cooking. At this point, the chips are still relatively plain, resembling lightly salted potato crisps. To give them their final taste, they must go through the seasoning process. The chips enter a large rotating drum, which is a key part of the flavoring system. This drum functions much like a giant tumbler, gently tossing the chips to ensure that each one is evenly coated with seasoning. However, before the seasoning can be applied, the chips must be lightly misted with a fine spray of oil. This thin coating of oil acts as an adhesive, allowing the seasoning to stick uniformly to each chip without clumping. Once the oil mist has been applied, the chips move further into the drum, where a precise amount of seasoning powder is dispensed. This powder is a proprietary blend of dehydrated spices, artificial and natural flavors, and other ingredients that create the distinct taste of each Pringles variety. Whether it's the classic original, sour cream and onion, barbecue, or any of the many other flavors available around the world, each seasoning mix is carefully crafted to deliver a consistent and recognizable taste. The rotation of the drum ensures that the seasoning is distributed evenly across all chips, preventing any one chip from receiving too much or too little flavor. This is crucial because even slight inconsistencies in seasoning distribution can affect the overall eating experience. Too much seasoning on one chip could make it overpowering, while too little could make it bland. The factory's precision-engineered system ensures that every chip in a can has the same delicious taste. To confirm that the seasoning has been applied correctly, automated sensors monitor the amount of seasoning powder dispensed and the overall coating level. These sensors use advanced optical and weight measurement technologies to detect any irregularities in the seasoning process. If an issue is detected, such as an uneven application or a deviation from the standard amount of seasoning, the system can automatically adjust to correct the problem in real time. Now fully seasoned, the chips continue their journey toward the final stages of production. At this point, they must be carefully handled to prevent breakage before they are packaged. Despite their sturdy design, Pringles are still delicate enough to crack if handled too roughly, so the conveyor system is designed to gently transport them through the factory. Before reaching the packaging area, the chips pass through another quality control checkpoint. High-speed cameras and sensors inspect each chip to ensure that they meet the brand's strict standards. Any chips that are overly browned, misshapen, or broken are automatically removed from the line. These rejected chips do not go to waste. They are often ground down and repurposed as part of the raw ingredient mixture for new batches, minimizing food waste in the production process. Now, with their perfect shape, crisp texture, and flavorful coating, the chips are ready for packaging. However, the packaging process itself is an essential part of what makes Pringles so unique. Unlike traditional potato chips, which are packed into bags that allow for some degree of breakage, Pringles are carefully stacked inside rigid cylindrical cans. This design ensures that they remain intact from the moment they leave the factory to the time they are opened by consumers. As the chips approach the packaging area, specialized machines align them into precise stacks. These machines use gentle vibrations and suction mechanisms to ensure that each stack is perfectly arranged before being inserted into the canisters. The stacking process is incredibly precise. Any misalignment could cause the chips to break during transportation. At this point, the Pringles are nearly ready to be sealed and sent out for distribution, but there are still a few final steps left to complete before they can reach store shelves. The packaging must ensure freshness, provide product protection, and meet branding and labeling requirements. In the next stage, the stacked chips will be inserted into cans, sealed for freshness, and prepared for shipment. With the freshly seasoned chips perfectly stacked and aligned, the Pringles are now ready for the crucial packaging stage. This process is just as important as the manufacturing and cooking steps, as it ensures that the chips remain intact and fresh until they reach consumers. Unlike traditional potato chips, which are packed loosely in bags that allow for some level of breakage, Pringles are carefully placed into rigid cylindrical cans, a signature feature that sets them apart from other snack foods. The packaging process begins with the automatic loading of the Pringles stacks into their respective canisters. These canisters, made from a combination of cardboard and aluminum lining, are designed to provide structural support, protecting the delicate chips from breaking during transport. The cans arrive at the packaging station in a flattened state and are quickly formed into their cylindrical shape by specialized machinery. The inner lining of the cans is coated with a food-safe aluminum layer, which helps to preserve freshness by preventing exposure to moisture and air. Once the cans are fully formed, they are transported to the filling station, where the Pringles stacks are precisely inserted into them. This process requires extreme precision, as any misalignment could cause the chips to shift or break. A combination of gentle vibrations and suction mechanisms ensures that the stacks remain stable as they are guided into the canisters. If even a single chip in the stack is out of place, the entire batch may be rejected to maintain quality standards. As the filled cans move along the conveyor, they reach the sealing station, where a thin foil seal is applied to the top of each canister. This foil seal serves multiple purposes. It locks in freshness, prevents air from entering, and ensures that the chips remain crisp for an extended period. The application of the seal is a highly controlled process that uses a combination of heat and pressure to create an airtight bond between the foil and the can's rim. Automated sensors continuously monitor the sealing process, detecting any imperfections or leaks. If a faulty seal is identified, the can is removed from the production line and either reprocessed or discarded. After the foil seal is in place, a plastic lid is applied to the top of the can. This lid serves as a secondary protective barrier and allows consumers to reseal the container after opening. The lids are typically made from lightweight but durable plastic that ensures a secure fit while remaining easy to remove. Before being placed onto the cans, the lids are inspected for defects, such as warping or cracks, which could compromise the product's freshness. With the Pringles cans now fully assembled and sealed, they move toward the labeling and branding station. Here, pre-printed labels featuring the Pringles logo, flavor designation, and nutritional information are carefully wrapped around each canister. These labels are made from high-quality materials that are resistant to moisture and tearing, ensuring that they remain intact throughout the product's journey from the factory to store shelves. A combination of heat and adhesive is used to secure the labels in place, ensuring a smooth, wrinkle-free application. Once labeled, the finished cans undergo another round of quality control checks. Automated cameras and sensors scan each can to verify that the labels are correctly applied and free of defects. Any cans with misaligned or damaged labels are removed from the line and either relabeled or discarded. Additionally, random samples from each batch are taken for more detailed inspections, where factory workers check for overall product integrity, including stack alignment, sealing effectiveness, and crispness. After passing the final quality control checks, the Pringles cans are grouped together for bulk packaging. This step involves placing multiple cans into larger cardboard cartons or shrink-wrapped bundles, which make transportation and stocking more efficient. The bulk packaging process is automated, with robotic arms carefully arranging the cans into pre-formed boxes or wrapping them in durable plastic film. The goal is to maximize space efficiency while ensuring that the cans are securely held in place to prevent movement during shipping. Once the bulk packaging is complete, the cartons are sealed and labeled with batch numbers, expiration dates, and tracking information. These labels allow for easy inventory management and ensure that products can be traced back to their specific production batch if necessary. The cartons are then stacked onto pallets, which are loaded onto trucks for distribution to retailers, supermarkets, and convenience stores around the world. Before being shipped out, the finished products undergo a final inspection to verify that the correct quantities and flavors have been packed for each order. Logistics teams coordinate with distribution centers to determine the most efficient shipping routes, ensuring that Pringles reach their destinations as quickly and cost-effectively as possible. Since Pringles are a globally recognized brand, this distribution network spans multiple countries, requiring careful coordination between factories, warehouses, and retailers. Throughout this entire process, Pringles manufacturers adhere to strict hygiene and safety regulations to ensure product quality and consumer safety. Factory workers follow rigorous sanitation protocols, wearing protective gear such as gloves, hairnets, and face masks to prevent contamination. The production facilities are regularly inspected by quality assurance teams and food safety organizations to ensure compliance with industry standards. In addition to maintaining high production standards, Pringles manufacturers are constantly exploring ways to improve sustainability and reduce waste. The company has implemented initiatives to minimize environmental impact, such as optimizing energy usage in production plants, recycling excess packaging materials, and reducing food waste by repurposing rejected chips and excess dough. In some regions, Pringles packaging has been redesigned to use more eco-friendly materials, with ongoing efforts to further enhance the sustainability of the product. While the cans of Pringles are now ready to be shipped to stores, the journey does not end there. Once they arrive at retail locations, they must be carefully stocked to ensure they remain in pristine condition for customers. Store employees follow specific stocking guidelines to prevent the cans from being crushed or stacked improperly. The cylindrical shape of the canisters allows them to be displayed neatly on shelves, creating an organized and visually appealing presentation. For consumers, the convenience of Pringles packaging is one of its most attractive features. The resealable lid allows snackers to enjoy the chips at their own pace while keeping them fresh between servings. Unlike traditional chip bags that often trap excess air and lead to crushed chips, the rigid canister provides a level of protection that helps maintain the product's quality. The success of Pringles is not only due to the meticulous manufacturing process, but also to the brand's ability to continually innovate. Over the years, new flavors and limited edition varieties have been introduced to cater to different tastes and cultural preferences. Research and development teams work to create unique seasoning blends and textures that keep consumers engaged with the brand. In some cases, local flavors are developed exclusively for specific markets, adding an element of regional customization. With the fully sealed and labeled Pringles cans ready for shipment, the final step in the manufacturing process involves distribution and logistics. Once the pallets of Pringles leave the factory, they are sent to distribution centers where they are sorted based on destination. From here, they are shipped to retail locations around the world, including supermarkets, convenience stores, vending machines, and online retailers. One of the key advantages of Pringles' packaging is its durability. Unlike traditional potato chips that are shipped in large bags, prone to air compression and breakage, Pringles' rigid canisters allow for efficient stacking and transport without excessive damage. This means fewer chips are wasted due to breakage during shipping, making the product more cost-effective and reducing food waste. At the retail level, Pringles cans are often displayed in neat, vertical arrangements on shelves, taking advantage of their cylindrical shape. This design not only protects the chips, but also maximizes shelf space compared to bulky chip bags. Supermarkets and convenience stores follow specific stocking guidelines to ensure that Pringles cans remain undamaged and easily accessible to customers. Once purchased, consumers benefit from the resealable can, which keeps the chips fresh longer than traditional bags. Unlike conventional chip bags that often allow air to seep in after opening, leading to stale chips, Pringles' airtight design helps maintain their signature crunch over multiple servings. This has been a significant selling point for the brand and one of the reasons for its continued popularity. Beyond the production process, the Pringles brand continues to evolve. The company regularly develops new flavors, incorporating regional tastes and limited edition releases to cater to different markets. Flavors such as wasabi, pizza, and even dessert-inspired varieties have been introduced over the years, keeping the brand relevant and exciting for consumers. In recent years, sustainability has become a growing concern, leading to efforts to improve the recyclability of Pringles packaging. While the multi-material composition of the can presents challenges for recycling, Pringles manufacturers are exploring alternative packaging solutions that reduce environmental impact while maintaining product integrity. As technology advances, the future of Pringles manufacturing may include even greater automation, improved energy efficiency, and smarter quality control systems. Artificial intelligence and machine learning could further refine production, ensuring even higher consistency in shape, flavor, and texture. Additionally, new ingredients and production techniques could be developed to create healthier or more sustainable variations of Pringles. The journey of a Lay's potato chip begins long before it reaches the factory. It starts in carefully selected farms, where high-quality potatoes are cultivated under strict agricultural standards. Lay's manufacturers work closely with farmers to ensure that only the best potato varieties are used, focusing on those with the right balance of starch and moisture. This is crucial because the composition of the potato determines how well it crisps during frying and how it absorbs seasoning. The selected varieties are chosen for their ability to produce a light, crunchy texture while maintaining the signature taste that has made Lay's a household name. The potatoes are grown in rich, fertile soil, monitored throughout the growing season to ensure optimal size, shape, and starch content. Farmers pay close attention to irrigation, pest control, and harvesting schedules to meet the brand's high standards. When the potatoes reach the perfect stage of maturity, they are harvested using specialized machinery designed to minimize bruising and damage. The harvested potatoes are loaded into large trucks and transported to Lay's production facilities, where the real transformation begins. Upon arrival at the factory, the potatoes undergo an initial inspection to check for quality, size, and any visible defects. Automated sorting machines and human inspectors work together to identify and remove any potatoes that do not meet the necessary standards. The goal is to ensure that every potato entering the production line will contribute to the consistent, high-quality chips that consumers expect. The selected potatoes are then stored in climate-controlled environments to maintain their freshness until they are ready to be processed. Before they can be turned into chips, the potatoes must be thoroughly cleaned. They pass through high-powered washing systems that remove dirt, pesticides, and any residual soil from the harvesting process. This step is crucial, as even tiny impurities could affect the taste and texture of the final product. The cleaning process uses jets of water and rotating brushes that scrub the potatoes without damaging their structure. After washing, the potatoes move along a conveyor belt toward the peeling station. Peeling is an essential step in ensuring a smooth and uniform surface for slicing. Large industrial peeling machines use abrasion or steam to remove the skin efficiently while preserving as much of the potato as possible. The peeling method used depends on the specific facility, but both techniques are designed to be fast and effective, ensuring that the potatoes retain their natural integrity. Any residual skin is removed by high-pressure water sprays before the potatoes move to the next phase of production. With the potatoes now clean and peeled, they are ready for slicing. The slicing process is one of the most critical steps in determining the texture and crispness of the final chip. The potatoes are fed into high-speed rotary slicers equipped with precision-engineered blades. These blades cut the potatoes into uniformly thin slices, ensuring that each chip cooks evenly. The thickness of the slices varies depending on the type of Lay's chip being produced, whether it's classic, wavy, or kettle cooked. The precision of the slicing process is carefully monitored, as even slight variations in thickness can affect the frying process and overall quality. Once sliced, the potato pieces undergo another quick rinse to remove excess surface starch. This helps prevent the chips from sticking together during frying and contributes to the signature crisp texture. The slices then move through an automated dewatering system where excess moisture is removed before they enter the frying stage. Proper moisture removal is essential, as too much water content could interfere with the frying process and create inconsistencies in texture. At this point, the sliced and dried potatoes are prepared for frying. The frying process is meticulously controlled to ensure that every chip reaches the perfect level of crispness. Conveyor belts carry the slices toward massive industrial fryers filled with hot oil. The oil temperature is carefully maintained to ensure consistent cooking, and the frying time is precisely measured to achieve the ideal golden brown color. The type of oil used varies depending on the region and product line, but it is always selected for its ability to enhance the flavor and texture of the chips while meeting health and safety standards. As the potato slices enter the fryer, they begin to bubble and sizzle. their moisture rapidly evaporating as they absorb just the right amount of oil. This transformation is what gives Lay's chips their signature crunch. The frying process is closely monitored by sensors and quality control specialists, ensuring that each batch meets the company's strict standards. The duration of frying varies depending on the type of chip, but every second counts in achieving the perfect crispness. The chips continue their journey along the production line, still hot from the fryer. At this stage, they are carefully drained of excess oil using advanced drying techniques. This step is crucial, as too much residual oil could make the chips greasy, while too little could impact their mouthfeel. A fine balance must be maintained to ensure that each chip retains the light, crispy texture that Lay's is known for. With the chips now cooked to perfection, they move forward to the seasoning stage, where their flavor truly comes to life. Lay's offers a wide variety of flavors, from the classic lightly salted to bold, complex seasonings that cater to different tastes and preferences. Each flavor blend is created using a combination of spices, herbs, and other ingredients that have been meticulously tested for balance and intensity. The seasoning process is highly specialized to ensure even distribution, guaranteeing that every chip is coated with the perfect amount of flavor. Before seasoning is applied, the chips pass through a gentle tumbling system that helps prepare them for even coating. This ensures that every chip has an optimal surface for seasoning adherence. A light mist of oil may be added at this stage to help the seasoning stick, ensuring that every bite delivers the intended flavor experience. The seasoning is then evenly sprinkled over the chips using automated dispensers that precisely measure the amount applied. Quality control specialists continuously test and monitor the seasoning levels, ensuring that each batch is consistent. Lay's has developed advanced flavoring systems that use real-time feedback to adjust the seasoning application as needed. This ensures that no chip is under-seasoned or over-seasoned, preserving the product's signature taste. Once the chips have been seasoned to perfection, they continue moving along the production line toward the next stage of the process. The chips must be handled carefully to prevent breakage and ensure they retain their structure as they progress through the factory. The journey is far from over, with several more key steps left before they are ready for packaging and distribution. As the freshly seasoned chips continue moving through the production line, they enter one of the most critical stages of the entire process: quality control. Lay's has built its reputation on delivering chips that are consistent in taste, texture, and appearance. And this is only possible through rigorous inspections at multiple points along the manufacturing process. Each chip must meet exacting standards before it is deemed fit for packaging, so quality control systems are an integral part of the factory's operation. The first stage of quality control involves high-speed cameras and sensors that scan the chips as they pass along the conveyor belt. These cameras are equipped with advanced imaging technology that detects any chips that are misshapen, burnt, undercooked, or broken. If a chip does not meet the specified criteria, it is automatically removed from the production line using precision air jets that quickly and efficiently separate defective chips from the rest. This ensures that only chips of uniform shape, size, and color continue on their journey. Alongside the automated quality control systems, trained inspectors conduct manual checks at various points in the production process. These specialists sample chips from every batch, testing for crunchiness, oil content, seasoning distribution, and overall flavor consistency. Taste tests are regularly performed to ensure that every chip has the signature Lay's flavor profile. If an inconsistency is detected, adjustments can be made immediately to the frying temperature, seasoning application, or oil levels to correct the issue before it affects a large quantity of product. While the chips are still warm, they move along the conveyor belt toward the cooling system. The cooling stage is essential, because the chips must be brought down to a stable temperature before they can be packaged. If the chips were packed while still warm, condensation could form inside the packaging, leading to sogginess or loss of crispness. To prevent this, the chips pass through cooling tunnels where controlled air circulation gradually reduces their temperature. This step ensures that when the chips reach the packaging stage, they maintain their light, crunchy texture. Once cooled, the chips approach another crucial phase, sorting and weighing. The production line is equipped with highly sensitive scales that measure precise portions of chips. These automated weighing systems are programmed to dispense an exact amount of chips into each bag, ensuring consistency across all packages. The portioning must be extremely precise to meet regulatory weight standards and ensure that customers receive the correct amount of product. Any deviations in weight trigger an automatic adjustment in the dispensing system. After portioning, the chips are directed into the bagging machines, where specially designed Lay's packaging material awaits them. The bags are made from multi-layered, high-barrier film that helps protect the chips from moisture, light, and oxygen, 3 factors that can negatively impact their freshness and taste. The packaging is specifically designed to extend shelf life while preserving the signature crunch and flavor. As the chips drop into the open bags, a stream of nitrogen gas is injected into each bag before sealing. This process, known as nitrogen flushing, serves a crucial purpose. By replacing the oxygen inside the bag with nitrogen, the factory prevents oxidation, which can cause the chips to become stale over time. The nitrogen also helps create a cushioning effect inside the bag, preventing the chips from breaking during transportation and handling. The sealed bags are then heat sealed using precision machinery that ensures an airtight closure. Once sealed, the freshly packed bags of Lay's chips move along the conveyor to the final quality control checkpoint. Here, inspectors verify that the bags are sealed properly, that they contain the correct weight, and that there are no issues with the packaging material. Automated sensors scan the bags for any irregularities, such as improper sealing or printing errors on the labels. If any issues are found, the defective bags are removed from the line before they reach distribution. At this point, the bags are ready for bulk packaging. Large robotic arms carefully arrange the individual chip bags into larger cartons or cases, which are then sealed and labeled for shipment. The cases are stacked onto pallets in an optimized configuration to maximize space efficiency in shipping trucks and storage facilities. The pallets are then loaded onto trucks and transported to Lay's distribution centers, where they are sorted based on their destination. While the chips are being prepared for distribution, data is continuously being collected from the production line to track performance and efficiency. Advanced factory management systems monitor every aspect of the manufacturing process, from the amount of raw materials used to the speed of production. This data allows production teams to identify trends, detect potential inefficiencies, and make real-time adjustments to improve overall operations. Lay's chips are manufactured in multiple facilities worldwide, ensuring that they can reach markets across different regions quickly and efficiently. Each factory follows strict food safety guidelines and adheres to regional regulations to maintain high product standards. The factories are designed to operate at peak efficiency while maintaining rigorous hygiene and cleanliness protocols. Workers in the facility adhere to strict sanitation procedures, including wearing protective clothing, gloves, and hairnets to prevent contamination. Even though the chips have left the factory and are on their way to retailers, the process does not stop there. Lay's has extensive logistics networks that ensure a steady supply of chips to stores and vending machines worldwide. Once the shipments arrive at retail locations, store employees follow best practices for stocking the product, making sure that older batches are sold first while newer shipments are placed behind them to maintain freshness. Lay's packaging is also designed for high visibility on store shelves, making it easy for customers to recognize their favorite flavors at a glance. The branding and design of the bags play a crucial role in marketing, with vibrant colors and flavor indicators clearly displayed. The bags are designed not only to protect the chips, but also to appeal to consumers through enticing imagery and messaging that highlights the quality and taste of the product. The popularity of Lay's chips has led to ongoing innovation in flavors, textures, and packaging options. Consumer feedback plays a major role in shaping new product developments, with research and development teams continuously testing new seasonings and chip varieties. Limited edition flavors and region-specific varieties allow Lay's to cater to different preferences across global markets. This constant evolution keeps the brand fresh and exciting for snack lovers worldwide. With the perfectly seasoned and packaged Lay's chips now prepared for distribution, the process continues beyond the factory walls. While the manufacturing process itself is a highly controlled and precise operation, what happens after the chips leave the factory is just as critical to ensuring that consumers receive a fresh, high-quality product. The logistics and supply chain management of Lay's chips play a crucial role in maintaining their availability across grocery stores, vending machines, and online retailers worldwide. Once the sealed bags are loaded into cartons, they are arranged onto pallets with extreme precision to maximize storage space and minimize movement during transportation. Each carton is labeled with important tracking information, including batch numbers, production dates, and expiration dates, allowing for full traceability. This ensures that if any quality issues arise, specific batches can be quickly identified and recalled if necessary. The pallets are then wrapped securely to prevent shifting during shipment, ensuring that the chips inside remain intact. From the factory, these pallets are transported to Lay's regional distribution centers, where they are sorted based on their intended destination. These distribution hubs act as the central points from which shipments are sent out to retail locations. Temperature and humidity levels inside the warehouses are carefully maintained to ensure that the chips do not absorb excess moisture, which could compromise their crisp texture. At this stage, automated inventory management systems help keep track of shipments, ensuring that stores receive the correct quantities and flavors based on regional demand. As the chips are shipped out to grocery stores, convenience stores, gas stations, and other retail locations, the logistics team continuously monitors their movement. The goal is to minimize the time it takes for a freshly produced bag of chips to reach the shelves, preserving the crunch and flavor that customers expect. Lay's supply chain is designed for efficiency, with trucks following optimized routes to deliver products as quickly as possible. In some cases, chips that are produced in the morning can be on store shelves by the afternoon in nearby regions. At retail locations, store employees are trained to handle Lay's chips carefully during stocking. The lightweight nature of the packaging means that the bags can be susceptible to compression if not stacked correctly. Retailers follow strict guidelines to ensure that chips are displayed properly, with newer shipments placed behind older stock to maintain freshness. In vending machines, the placement of Lay's chips is also optimized to prevent excessive movement that could lead to breakage. The careful handling of the product at every stage is what ensures that customers receive whole, unbroken chips when they open a bag. The journey of Lay's chips does not stop at store shelves. Consumer feedback plays a vital role in shaping future production decisions. Lay's has dedicated teams that analyze purchasing trends, customer reviews, and market demands to determine which flavors and varieties are most popular. This data influences everything from production volume to regional flavor innovations, ensuring that Lay's continues to evolve with consumer preferences. In some cases, limited edition flavors are introduced based on feedback, with certain varieties becoming permanent offerings if they prove successful. As technology advances, Lay's continues to refine its production methods to improve efficiency, reduce waste, and enhance sustainability. One of the major challenges in large-scale snack production is minimizing the environmental impact of operations. To address this, Lay's has implemented initiatives to optimize energy usage in factories, improve water conservation during potato processing, and explore more sustainable packaging solutions. One of the key sustainability efforts involves reducing food waste during production. While some defective chips are removed during quality control, they are not simply discarded. Instead, these chips are often repurposed as animal feed or converted into biofuel, ensuring that as little as possible goes to waste. Additionally, potato scraps from the peeling and slicing process are collected and used for other food products or composting. The use of sustainable farming practices is also a priority for Lay's suppliers. Many of the farms that provide potatoes for Lay's have adopted eco-friendly techniques such as crop rotation, reduced pesticide usage, and precision irrigation to minimize water consumption. By working closely with farmers, Lay's ensures that its supply chain remains both environmentally responsible and efficient. Packaging innovation is another area of focus for Lay's as it looks for ways to make its chip bags more eco-friendly. Traditional chip packaging is made from multi-layered plastic film, which is designed to protect the chips from moisture and air exposure. However, the complex nature of this material makes it difficult to recycle. Lay's has been researching alternative packaging solutions that maintain freshness while reducing plastic waste. Some markets have already seen the introduction of biodegradable or recyclable chip bags, with further developments expected in the future. Automation and artificial intelligence are also playing an increasing role in Lay's production process. Advanced AI-driven quality control systems are being used to detect imperfections with greater accuracy than ever before. These systems can analyze thousands of chips per second, ensuring that every batch meets the highest standards. Additionally, robotic automation is improving efficiency in packaging and palletizing, allowing for faster and more precise handling of products. Beyond production, Lay's continues to engage with consumers through marketing, advertising, and promotions. The brand regularly collaborates with chefs, influencers, and food scientists to introduce new flavors and snack innovations. Limited edition seasonal flavors, cross-cultural fusion varieties, and unique textures like extra crispy or extra flavored chips keep the product line dynamic and exciting for customers. One of the most intriguing aspects of Lay's chips is how different regions have their own exclusive flavors, reflecting the local tastes and culinary preferences of different cultures. In Asia, flavors such as seaweed and spicy hot pot are popular, while in North America, barbecue and sour cream and onion remain among the best sellers. Europe has its own set of unique offerings, including flavors inspired by traditional cheeses and herbs. The ability to adapt to different markets while maintaining the core essence of Lay's chips is what has helped the brand maintain its global appeal. At its core, the production of Lay's chips is a blend of science, technology, and tradition. The balance between maintaining the classic quality that customers expect while continuously innovating is what keeps Lay's at the forefront of the snack industry. From the careful selection of potatoes to the high-speed frying process, precise seasoning application, and advanced packaging techniques, every step is optimized to ensure consistency, flavor, and crunch in every bite. The cycle of chip production never truly stops. Even as one batch is being transported to stores, another is already being prepared in the factory. The efficiency of the Lay's production process ensures that there is always a fresh supply of chips available for consumers. The combination of high-tech manufacturing, sustainability initiatives, and a deep understanding of consumer preferences keeps Lay's chips at the top of the snack food market, continuously evolving to meet the changing tastes and expectations of snack lovers around the world. PepsiCo takes extreme care in sourcing and treating water to ensure the final product is free from impurities, contaminants, and off flavors. Without this careful preparation, the beverage could have inconsistencies in taste, appearance, and carbonation retention. The journey starts with sourcing water from natural springs, municipal supplies, or underground wells, depending on the bottling plant's location. However, regardless of its origin, this water must go through extensive treatment to meet PepsiCo's strict quality standards. The process begins with initial screening, where water passes through coarse filters that remove large particles such as dirt, sand, and debris. This is followed by sedimentation, a method that allows heavier impurities to settle at the bottom while the cleaner water moves forward in the process. Once the larger impurities are removed, the next step is carbon filtration. This step is crucial for removing chlorine, organic compounds, and any unwanted odors or tastes that could interfere with the Pepsi formula. Activated carbon filters contain a highly porous material that traps chemical impurities while allowing pure water to flow through. This process not only improves the taste of the water, but also enhances its ability to mix well with the other ingredients later in production. But up next is the reverse osmosis process, one of the most advanced purification techniques used in beverage manufacturing. Reverse osmosis involves forcing water through an ultra-fine membrane under high pressure, effectively removing even the tiniest dissolved particles, including salts, minerals, and microscopic contaminants. This ensures that the water is as pure as possible before it becomes part of the Pepsi formula. To further refine the water, it undergoes ultraviolet sterilization. This step is essential for eliminating any remaining bacteria, viruses, or other microorganisms that could compromise the safety and shelf life of the beverage. High-intensity UV light disrupts the DNA of these microorganisms, rendering them inactive without the use of chemical disinfectants. Finally, before the purified water is stored, it goes through an ozonation process. Ozone, a highly reactive form of oxygen, is injected into the water to act as a natural sanitizer. This step ensures that the water remains free from microbial contamination while it is held in large stainless steel storage tanks, awaiting the next phase of production. Now that the water has been meticulously purified, it must be precisely balanced to create the ideal base for Pepsi. Even though reverse osmosis removes most dissolved solids, a controlled amount of specific minerals is added back into the water to optimize taste and improve its ability to retain carbonation. This step is carefully monitored as the mineral composition of the water can impact the final mouthfeel and texture of the beverage. With the water fully prepared and stored in sanitary tanks, it is now ready to be mixed with the other key ingredients that will give Pepsi its distinctive flavor. But before moving on to mixing, each batch of purified water is rigorously tested for quality. Samples are taken from the storage tanks and analyzed in PepsiCo's in-house laboratories. Scientists and quality control experts measure pH levels, mineral content, and overall purity, ensuring that each batch meets the company's global standards. If any irregularities are detected, the water is either reprocessed or discarded, preventing any inconsistencies from affecting the final product. Now that the water has been meticulously purified and stored in sanitized tanks, the next crucial step in the Pepsi manufacturing process is the preparation and addition of sweeteners. Sweeteners play a fundamental role in defining the flavor profile of Pepsi, contributing to its signature taste while also affecting mouthfeel, viscosity, and overall balance. The selection, processing, and precise blending of these sweeteners are critical to ensuring that every bottle and can of Pepsi maintains consistency across different production facilities worldwide. In most regions, Pepsi is sweetened with high fructose corn syrup, a liquid sweetener derived from cornstarch. However, in some markets, particularly in countries where cane sugar is more widely available or preferred, sucrose from sugarcane or sugar beets is used instead. Regardless of the source, the sweetener must be carefully refined and processed before being added to the beverage. The journey of high fructose corn syrup begins with corn milling, where harvested corn is cleaned, steeped, and ground into a slurry to separate the starch from the fiber, protein, and germ. The extracted starch is then subjected to enzymatic processing, where it is converted into glucose. A second enzyme is introduced to transform a portion of the glucose into fructose, increasing its sweetness. The result is a thick, viscous syrup that is then further refined, filtered, and tested to ensure the correct balance of glucose and fructose. The most commonly used variety in soft drinks is HFCS 55, which contains approximately 55% fructose and 45% glucose, closely mimicking the sweetness profile of cane sugar. For regions that use sucrose instead of HFCS, the sugar is derived from either sugarcane or sugar beets. Sugarcane is harvested, crushed to extract juice, and then boiled to concentrate the sugar, forming crystallized sucrose. Sugar beets, on the other hand, are sliced and soaked in hot water to extract sugar, which is then purified and crystallized. In both cases, the raw sugar undergoes extensive refining to remove impurities and ensure a uniform, pure sweetener. Once the sweetener is ready, it must be dissolved into a concentrated syrup before being mixed with other ingredients. In a dedicated mixing tank, the high fructose corn syrup, or dissolved sucrose, is blended with purified water in precise proportions to create a uniform, sweetening solution. This syrup is continuously agitated to prevent crystallization and ensure a consistent texture. To maintain Pepsi's exact sweetness level, refractometers are used to measure the syrup's sugar concentration, ensuring it falls within the specified range. At this stage, the syrup is also subjected to rigorous quality control testing. Laboratory technicians take samples from each batch and analyze them for purity, consistency, and microbial safety. Any inconsistencies in sweetness or viscosity could alter the taste of the final product, so adjustments are made, if necessary, before moving on to the next step. Now that the sweetener has been perfectly prepared, it is time to introduce the key flavoring components that define Pepsi's distinctive taste. Pepsi's flavor is the result of a complex blend of natural and artificial flavorings, including citrus oils, spice extracts, and caramel notes. The exact recipe remains a closely guarded secret, known only to a select few within the company. But it is widely understood that ingredients like orange oil, lemon oil, vanilla, cinnamon, nutmeg, and cola nut extract contribute to the drink's signature profile. The flavoring components are carefully blended into a concentrated mixture known as the flavor base. This highly concentrated liquid is prepared in a separate, sterile mixing tank, where precise measurements of each ingredient are combined under controlled conditions. Some of these ingredients, particularly the essential oils, must be emulsified using stabilizers to ensure they mix properly with the water-based formula of Pepsi. Without proper emulsification, the oils could separate from the rest of the beverage, leading to inconsistent flavor distribution. Phosphoric acid is then added to the flavor base, providing Pepsi with its signature sharpness and tangy aftertaste. This acid also plays a crucial role in preserving the beverage by inhibiting microbial growth. The level of acidity is carefully controlled to balance the sweetness of the drink and enhance its overall flavor. Caramel color, which gives Pepsi its deep brown hue, is another essential ingredient added at this stage. This colorant is created by heating sugar compounds under controlled conditions, resulting in a stable and safe coloring agent. The intensity of the caramel color is strictly regulated to ensure that every bottle of Pepsi has the same visual appeal. Once the flavor base is complete, it must be thoroughly mixed with the sweetener solution to create the final syrup that will be used in the soft drink. This blending process takes place in large stainless steel tanks, where high-powered mixers ensure even distribution of all ingredients. The proportion of sweetener to flavor base is precisely measured, as even a slight deviation could alter the taste of the final product. Before the syrup is approved for use, samples are taken and analyzed in a quality control lab. Tests include pH measurement, viscosity checks, and sensory evaluations, where trained tasters confirm that the syrup matches Pepsi's standard flavor profile. These rigorous quality checks ensure that every batch of syrup is identical, maintaining Pepsi's global consistency. Once the syrup has passed all quality control tests, it is stored in temperature-controlled holding tanks, ready to be mixed with carbonated water. These tanks are kept under strict sanitary conditions to prevent contamination and preserve the integrity of the syrup. But up next is one of the most critical aspects of the Pepsi production process: carbonation. This step is responsible for the effervescence and refreshing sensation that consumers associate with soft drinks. Without proper carbonation, Pepsi would lose its signature fizz, altering the drinking experience. The process of infusing the beverage with carbon dioxide is both a science and an art, requiring precise control over temperature, pressure, and gas concentration. To begin the carbonation process, purified water is first chilled to near freezing temperatures. The reason for this is that carbon dioxide dissolves more efficiently in cold water than in warm water, ensuring maximum carbonation retention. The chilled water is then injected with high purity CO2 gas under controlled pressure, creating carbonated water. This water is then carefully blended with the pre-mixed syrup in an exact ratio, typically around 5 parts carbonated water to 1 part syrup. The precise proportion ensures the correct balance of flavor, sweetness, and fizziness in the final beverage. Maintaining the right level of carbonation is crucial, as it directly affects the mouthfeel and shelf life of the product. If the carbonation is too low, the drink will taste flat and less refreshing. If it is too high, the beverage may be overly acidic or cause excessive foaming during packaging. To ensure consistency, carbonation levels are continuously monitored using pressure sensors and dissolved CO2 analyzers. The newly carbonated Pepsi must now be handled carefully to prevent the loss of carbonation before packaging. At this stage, the beverage is kept under constant pressure in specialized holding tanks to maintain CO2 solubility. Any sudden release of pressure could cause the carbon dioxide to escape, resulting in a less fizzy drink. With the Pepsi now fully mixed, carbonated, and held under precise pressure conditions, the next step is bottling and packaging. This is one of the most intricate parts of the manufacturing process, requiring extreme precision, speed, and cleanliness to ensure that every bottle and can of Pepsi is filled, sealed, and prepared for distribution without losing carbonation or quality. The bottling process must take place in a sterile environment to prevent contamination, and the machinery involved operates at incredibly high speeds to keep up with global demand. The first part of this process involves the preparation of bottles and cans. Pepsi is available in a wide range of packaging formats, including glass bottles, aluminum cans, and plastic bottles made from polyethylene terephthalate. Each type of container has its own preparation requirements, but all must be thoroughly cleaned and sterilized before being filled. For plastic bottles, the process begins with small, preformed PET molds called preforms. These preforms are heated to a specific temperature and then rapidly inflated using high-pressure air inside a blow molding machine. This machine expands the preforms into their final bottle shape, ensuring uniform thickness and durability. The freshly molded bottles are then conveyed into a high-speed rinsing station. where they are thoroughly washed with filtered water and food-safe sanitizing agents to remove any potential contaminants. Glass bottles undergo a more rigorous cleaning process since they are often reused. They are first soaked in a high-temperature caustic solution to break down any residue from previous use, followed by multiple rinses with clean, filtered water. Finally, they pass through a steam sterilization chamber to ensure that no microorganisms remain. Aluminum cans, on the other hand, arrive at the bottling plant pre-formed and ready to be filled. However, before filling, they are sent through a high-pressure air jet cleaning system that blasts away dust and debris. Since aluminum cans are highly sensitive to corrosion, a thin food-safe lining is applied inside each can to prevent any reaction between the beverage and the metal. Now that the bottles and cans are fully prepared, the filling process can begin. The carbonated Pepsi is transported through a network of pressurized stainless steel pipes that maintain the beverage's optimal CO2 concentration and temperature. The filling machines operate at high speeds, capable of processing thousands of containers per minute. For PET and glass bottles, filling is done using gravity-based or counter-pressure filling systems. In a counter-pressure system, the bottle is first pressurized with CO2 before the Pepsi is introduced. This prevents foaming and excessive carbonation loss during filling. The precise amount of liquid is dispensed into each bottle, with sensors ensuring that no underfilled or overfilled bottles proceed down the production line. Aluminum cans require a slightly different approach. Since they are more prone to CO2 loss due to their wide openings, the filling nozzles are designed to minimize turbulence as the liquid enters. The cans are quickly filled and then topped with a small injection of nitrogen gas to prevent oxidation before being sealed. Now that the containers are filled with carbonated Pepsi, the next critical step is sealing. This process must be done immediately after filling to prevent carbonation loss and contamination. For plastic and glass bottles, this involves capping. Screw-on plastic caps are applied to PET bottles using high-speed rotary capping machines, which tighten each cap with precise torque to ensure a secure seal. Glass bottles, often used for premium or international markets, are sealed with either metal crown caps or twist-off caps, depending on the region. Aluminum cans are sealed using a double seaming process. A lid, which contains an integrated pull tab, is placed on top of the can and then mechanically crimped around the rim. This creates an airtight seal that locks in carbonation and prevents leakage. With all the containers now sealed, they move on to the quality control phase. At this stage, random samples are pulled from the production line and tested for multiple factors, including fill level, carbonation retention, pressure stability, and contamination. Advanced X-ray and laser scanning systems inspect each bottle and can to ensure that there are no foreign particles, dents, or defects in the packaging. Any defective units are immediately rejected and removed from the batch. Once the beverages pass quality control, the containers proceed to labeling. Each bottle and can receives a label that includes branding, nutritional information, ingredient lists, and regulatory compliance markings. PET bottles have labels applied using heat shrink or pressure-sensitive label machines, while aluminum cans typically have their designs pre-printed onto the metal surface. After labeling, the bottles and cans are grouped into multi-packs for retail distribution. This process involves bundling them into various configurations, such as 6-packs, 12-packs, or full cases. Plastic shrink wrap, cardboard trays, or molded carrying handles are used to secure the multi-packs for easy transportation. The completed packs are then stacked onto pallets in an organized manner and wrapped in stretch film to stabilize them for shipping. Now it's time for one of the most logistically challenging aspects of Pepsi production: distribution. The pallets of finished Pepsi products are moved to temperature-controlled warehouses where they are stored before being shipped to retailers, grocery stores, vending machines, and restaurants. Since Pepsi is produced in enormous quantities to meet global demand, distribution logistics must be precisely managed to ensure that every store and vendor receives fresh products. Pepsi's supply chain is a highly coordinated operation involving fleet management, refrigerated storage, and just-in-time delivery systems. Large distribution centers act as hubs where shipments are sorted based on region and customer demand. Trucks, rail transport, and even cargo ships are used to move massive volumes of Pepsi across countries and continents. Once the products arrive at their final destinations, they are placed in cold storage or directly onto store shelves. In grocery stores and supermarkets, Pepsi is often stored in temperature-controlled sections to maintain freshness. Restaurants and fast food chains receive large volumes of Pepsi in bulk containers, which are connected to soda fountains for on-demand dispensing. Throughout this entire process, PepsiCo maintains strict inventory tracking and quality assurance programs. Each batch of Pepsi is assigned a unique tracking code, allowing the company to trace products back to their production date, location, and ingredient sources. This ensures that in the event of a recall or quality issue, affected products can be quickly identified and removed from circulation. With the Pepsi bottles and cans now filled, sealed, labeled, and packed for distribution, one of the final but most crucial aspects of the manufacturing process is ensuring product consistency, longevity, and consumer satisfaction. Maintaining Pepsi's signature taste and quality across millions of bottles and cans requires an advanced system of quality control, storage optimization, and packaging innovation. Every aspect, from the shelf life of the product to the materials used in packaging, plays a role in ensuring that each Pepsi delivered to a consumer is as fresh and enjoyable as the last. The first key factor in Pepsi's shelf life and consistency is its ability to retain carbonation over time. Carbonation, which gives Pepsi its signature fizziness, is created by dissolving carbon dioxide into the liquid under high pressure. The challenge is ensuring that this CO2 remains trapped within the beverage from the moment it is bottled until it is opened by the consumer. To maintain carbonation, Pepsi uses specially designed bottles and cans that act as airtight barriers, preventing CO2 from escaping. Plastic bottles made from polyethylene terephthalate are engineered with multiple layers that slow down gas diffusion, preventing CO2 from seeping out over time. The thickness and structure of PET bottles are carefully optimized to balance durability with weight, ensuring that the bottles are strong enough to retain carbonation while remaining lightweight for transportation. Aluminum cans provide an even better barrier against gas loss. Their completely sealed structure ensures that no CO2 escapes, preserving the drink's fizziness for extended periods. Additionally, a protective food-grade lining inside each can prevent any reaction between the metal and the beverage, which could otherwise affect flavor. Glass bottles, often used for premium markets or limited edition versions of Pepsi, offer the best gas retention of all packaging types. Glass is completely impermeable, meaning that Pepsi stored in glass bottles maintains its carbonation for the longest period. However, glass is heavier and more fragile than plastic or aluminum, making it less practical for mass production and distribution. Another critical factor in product longevity is preventing oxidation. Exposure to oxygen can alter the taste of Pepsi, causing it to become flat and develop off flavors over time. To counter this, PepsiCo employs nitrogen dosing in certain packaging lines. This process involves injecting a small amount of nitrogen gas into PET bottles just before sealing. The nitrogen displaces any residual oxygen inside the bottle, reducing the risk of oxidation while also adding structural rigidity to the bottle, preventing it from collapsing under vacuum pressure. Beyond carbonation and oxidation control, preservatives also play a role in maintaining Pepsi's freshness. While the beverage's acidity and carbonation naturally inhibit microbial growth, Additional preservatives such as sodium benzoate are included to extend shelf life further. These preservatives prevent mold, yeast, and bacterial growth, ensuring that Pepsi remains safe for consumption for months or even years after production. Now that the beverage's stability is secured, it must be stored and transported under optimal conditions. Pepsi is highly sensitive to temperature fluctuations, which can affect carbonation retention and overall flavor. As a result, warehouses, distribution centers, and retail storage areas are kept within a controlled temperature range to prevent heat exposure. Excessive heat can accelerate CO2 loss in plastic bottles and increase oxidation reactions, leading to a flatter, less refreshing drink. To counteract this, refrigerated warehouses are used in regions where high temperatures could compromise product quality. During transportation, trucks equipped with climate control ensure that Pepsi is not exposed to extreme heat or direct sunlight, both of which could degrade the beverage. Another major factor that affects Pepsi's taste consistency is the impact of light exposure. Ultraviolet light can break down some of the organic compounds in Pepsi's flavoring, leading to unwanted taste changes. This is why Pepsi bottles, particularly those made from PET, are designed with tinted or opaque plastic to reduce UV penetration. Aluminum cans and glass bottles naturally provide complete light protection, further ensuring product stability. Once Pepsi reaches its final retail destinations, whether in grocery stores, vending machines, or fast food chains, it is crucial that storage guidelines continue to be followed. Retailers are instructed to keep Pepsi stock rotated, ensuring that older products are sold first and newer shipments are stored properly. This helps maintain product freshness for consumers while preventing expired stock from sitting on shelves. Fast food chains and restaurants that serve Pepsi from soda fountains have additional steps to ensure taste consistency. Instead of pre-packaged bottles and cans, Pepsi is delivered to these locations in large pressurized syrup containers known as bag-in-box systems. These containers hold concentrated Pepsi syrup, which is mixed with carbonated water on demand through specialized dispensing machines. The bag-in-box system allows for efficient storage and prevents waste, as restaurants can control the syrup-to-water ratio for optimal taste. These systems are regularly maintained, with filters and carbonation settings adjusted to match the ideal flavor profile. Additionally, PepsiCo provides restaurants with quality control tools to measure CO2 levels and syrup concentration, ensuring that every poured glass tastes as good as a bottled Pepsi. With all these measures in place, Pepsi is now fully ready for consumers to enjoy. But beyond the immediate production and distribution, PepsiCo continually invests in research and development to improve manufacturing efficiency, sustainability, and packaging innovations. One of the company's most significant focuses in recent years has been reducing the environmental impact of its packaging. PepsiCo has made major advancements in recyclable PET bottle technology, developing bottles that contain post-consumer recycled plastic to cut down on waste. Additionally, the company has experimented with plant-based PET alternatives that reduce reliance on petroleum-based plastics. Aluminum cans have also been a major target for sustainability improvements. Since aluminum is highly recyclable, PepsiCo has worked to increase the amount of recycled aluminum used in can production. The company encourages consumers to participate in recycling programs, ensuring that cans are properly collected and reused. In some markets, PepsiCo has even introduced refillable glass bottle programs, allowing consumers to return used bottles for sanitation and reuse, significantly cutting down on single-use waste. Further technological advancements in bottling machinery have also improved efficiency in the production process.